on this call. Okay, so good. Now we're being recorded and okay, here you go. Here's my syllabus. I'm working on my syllabus. I'm not gonna have it today, but you know, as we first I want to find out about you before I finalize my syllabus, okay? But we are going to be meeting for lecture and lab from 8 a.m. to 2 p.m. online. It's going to be this address right here. Okay, and go online address, Zoom link. Zoom link is going to be the following. Let me get another. Oops, get it in here, out of the way. The link that we're going to use is my own Zoom account. And here you go. This one right in here, you should already have it. Link. Here you go. That's the one. The textbook that we are going to use is going to be those students who took the course with me. We are going to be using a different textbook, okay? Because this is I think it's a very good book. Is a traditional book. We has been around for maybe even 50 years or more. The Halliday and Resnick Fundamental of Physics 12 edition. Okay, and we start with chapter 15. They have a different organization there, and this chapter 15 and others. Okay, I'll give you the other chapters later on. And I'm going to be using my own physics note too, if you want to. By the way, this course here, ebook plus Wiley Plus, the Wiley Plus platform for homework is $69. Okay. I like this platform because it's much cheaper than the other one I was using with my other students. That was the WebAssign, and it's already set up out in there. Let me get also something here. There's a flyer for this platform. Shall I see this one? Interesting. 2022 summer. Okay, one more coming. Here you go. Summer classes schedule. Okay, here you go. Here's a flyer for you're going to need this course ID section, course section ID. Okay, I'm gonna post this flyer in my Canvas course. Okay, so you gotta log into Wiley Plus, go into this website, add the course, and you'll be using this course section ID. If you have any problems, let me know. And some of you, I presume that some of you already have purchased this access to Wiley Plus. Is that right? Can I hear from you? Anybody has already purchased the access to the Wiley Plus, or most of you don't have it yet? Let's see. You can chat with me. Let's see who can. Not yet. Okay, Anthony. Not yet. Amalia. Not yet. Okay. How many students you have? Yeah, Tiffany. Okay. Okay, so there is one student who has it. Most of you don't have it. Okay. Thank you for the feedback. Oh yeah, most of you don't have it, huh? Okay. Yeah. So my has purchased access already. Let's see who else. Wow, most of you haven't. Okay, okay. And who has access to a different platform for this course that you purchased previously? I want to know who has access to a different platform, okay? So let's do the following. Let's go through the syllabus, no, the attendance roster, and then I will ask you all these questions, okay? Here you go. Here's my, that would help help me design the course better and finding out what's your situation, what you have seen before. Okay, here you go. Yeah, most of you. Okay. So let's go ahead, and I'm gonna have the following questions. Okay, I want to know if where you took physics 37 and physics 38 in case you took physics 38. Okay, where? So some of you took physics 37 and physics 38 with you. Some of you took physics 37 and 38, most likely is Brian Gamble, right? And I believe that there are some students that coming from other schools too, that's not the LA Community College, that's not within the LA Community College district, okay? While plus access, and that's gonna be another question that I make to you, and another question here, other platforms, access to other platforms, okay? So those are the three questions that I want to know. Where you took physics 37 and physics 38, okay? If you already have Wiley Plus access or not, and if you have access to other platforms like WebAssign or any other one, okay? Access for this course. When I mean access to other platforms, for this course, for this specific course. That's what I mean. And we have 26 students. What's happening to everybody else? Just keep in mind that I'm going to be taking attendance. You should be present here online while we are meeting. This is a synchronous course. Okay, let's write it down here. You know, physics 39 today, June 13, 22. Introduction. This is a introduction. This is a synchronous course. You are required to interact with me. Okay, synchronous course, and there will be attendance. I'm going to take attendance throughout the meeting. So you are required to attend the live meeting. Okay, so here you go. Toby, are you there? Toby Adenugma. Okay, good. Okay, we're here. So let's see, Toby, you took physics 37, physics 38 with me, right?
Wait, what?
My question is, you took physics 37 and wait a minute, you took physics 38 with me, right? Physics
Yeah,
37. Yes, 37 you didn't take with me, right? You didn't take physics 37. Okay, so LHC, good. And why do you have Wiley Plus access, Toby?
I don't think so.
Okay, you
I need to
don't.
check. I'm not sure.
Okay. So, and the question is, did you, when you took the course with me, you purchased WebAssign access at the time?
Yes.
Okay, but you purchased only for the Physics 38 course, right? You didn't purchase for the others. Is that right?
No.
Okay, okay. So I'm gonna put it no. Okay. I'm gonna put
Okay.
because you do not have access for the Physics 39 through WebAssign, but no access to the Physics 39 course. Good. And let's see, Harun, Atif, are you there, Harun? I don't hear Harun. Let's see, Harun. Yeah, doesn't look like Harun is here, right? Musa, are you there, Musa? I don't see Musa in the list either. Okay. Jumai Bandel.
Hi, good
Hi, how are
morning.
you doing? How are you doing? Okay. So did you take, where you took Physics 37, 38, Jumai? I have an idea.
I actually didn't take 38. I took 37 with Professor Brian Gamble, like in
Okay.
winter session.
Okay.
And I have the Wiley Plus.
You have the Wiley Plus, okay.
But I don't have WebAssign. We took Beyond Labs. We used Beyond Labs to do our labs.
Oh, your labs, okay. Okay. Beyond Labs. Thank you for sharing this information with me about Beyond Labs. And go. Good. So Zachary Blue, Zachary Dominic Blue, are you there? Okay. If you know any of those students who didn't show up, please tell them that we are meeting online. Okay. So next one is Luis Crystal is Dean. Are you there? I don't see listed here. Okay. Brian Espino. Okay, is there network asynchronous? Okay. Well, it's like I said, this course is a synchronous one, and it's required to interact. I am required to interact with you, and consequently, you are required to interact with me as well. But we can talk about that during my office hours, okay? Dave, Brian's not here yet. Zakir Ferris. I don't see Zakir. Wow. Robert Foster's here, right? So you took, Robert, you took Physics 37 and Physics 38 with me, right? Both of them? Yeah, okay. You don't have Wiley Plus access, right? Did you purchase WebAssign for Physics 39, Faust, Robert? You think so? Okay, maybe. I'm gonna put maybe here. You do not know. Good. Pedro Flores, are you there? Thank you, Robert. Let's go to Pedro.
Yeah, I'm here. Good
Okay,
morning.
good. Good. So you took Physics 37 and Physics 38 with me, right?
Yeah, I did.
Okay. Do you have access to Wiley Plus?
No.
No. Did you purchase WebAssign access for the semester?
You haven't given us a code, so we can't purchase it yet. But
okay,
I can do that.
Oh, no. Wait a minute. Don't purchase WebAssign. We're going to be using Wiley Plus access. Okay.
Okay.
Okay. Some students purchase WebAssign for the whole duration of the course, and I want to make sure that that whether you did or not. Okay. So, but I presume that if you purchase in the past, if you purchase WebAssign in the past, I presume you purchase only for that specific semester, but not for multiple semesters. That's the question that I have. Lawrence Flores, are you there, Lawrence? I don't see Lawrence here in my list. Daniel Frady?
Here.
Okay, good, Daniel. So, okay, where did you took 37 and 38, physics 37, physics 38, Daniel?
I took 37 with you and Professor Gamble, and I haven't
Okay.
taken 38 yet.
Okay, so you took 37 with me and also Professor Gamble, is that right? Okay.
Yes.
Okay, so no 38 yet. Do you have Wiley Plus access? Did you purchase Wiley Plus access in advance?
I purchased it, but it expired, so.
It expires. Okay, so you don't have for this semester. Okay, did you purchase WebAssign access in advance?
Same as before.
Same
It's
as-
expired.
Okay, good. So you purchased just for the a specific semester that you took the course, right?
That is correct.
Okay, thank you very much, Daniel. Let's go to Amalia. Amalia Gale. I can see.
Hello,
she's-
Professor. Sorry,
Hi.
my phone wasn't working for a moment.
Okay, thank you. So let me see. Did you take physics 37 and physics 38? Who do you take physics 37? And if you took physics 38, who did you take it?
I actually took Physics 102
Which
at
college?
LACC.
Oh, LACC. Okay. And physics 38. Did you take physics 38?
I did not take Physics 38.
You did not. Okay. Do you have Wiley Plus access for this
No, I do
semester?
not.
Okay. Do you have access to other platforms that you purchased for this semester?
Not this semester or last semester, no.
Okay, good. Thank you. Tiffany, thank you very much, Amalia. Let me move to Tiffany. How are you doing, Tiffany?
Hello.
Yeah,
Can you hear me?
yeah, I can hear you loud and clear.
Yes, I'm here.
Okay, good. So did you take, who did you take physics 37? And if you took physics 38, who did you take that with?
I took them at West Valley College.
West LA, you said?
No, West Valley.
West Valley. Okay, West Valley. LA Valley College, right? There in the.
No, it's not in LA.
Oh, okay, it's another one. Okay, West Valley. And what about both 37 and 38, or?
I got 37 credit from AP, and I took 38 at West Valley.
In West Valley. Okay. Okay, you got credit and credit. So I'm gonna put like that, credit and West Valley. Good. Do you have access to Wiley Plus this semester?
No,
No. Okay. Do you have access to any other platform this semester?
no.
No. Okay. Good. Thank you very much. Let's move on. Olivia Kroger, are you there?
Hi, I'm here
Okay. So where do you take 37 and 38?
at UCSC,
USC, you said?
UC Santa Cruz.
UC Santa Cruz. Okay, UC Santa Cruz. Santa Cruz, man, that's the north of here, right? Nearby the bay, right? The Bay Area.
Yeah.
I was there. I was there before a long time ago. Okay, so UC Santa Cruz, and is that nearby Monterey Bay?
Yeah, it is.
Yeah. Okay, good. And you took both 37 and 38 at UCSC, is that right?
Yeah.
UCSC. Okay, good. Do you have access to Wiley Plus this semester?
No.
No. Okay. Any other access to any other platform this semester?
I don't think so.
You don't think so? Okay, good. Thank you. Thank you very much. Daniel Liang, are you there, Daniel? I don't see Daniel listed there. Okay, next is Anthony Lopez.
Hello,
Yeah.
good morning.
Good morning, Anthony. Okay, so you know the drill, right? Where do you take the previous physics courses?
Yeah, I've taken them both at Contra Costa College. It's in Northern California, where I am.
Okay, Northern California.
Yeah.
Well, how do you call it again?
Contra, so Contra Costa.
Contra Costa. Okay, Contra Costa. Good.
Mhm.
Do you have access to Wiley Plus?
Not yet.
Not okay. What about any other platform?
No.
No. Okay, that's good to know. Thank you very much. Let's go to Chup Lu. Chup is here, right? No. Nope, I don't see it. Okay, I thought I saw his name listed. Let's go, Dave DeMass. Are you there?
Yeah, I'm here.
Okay, good. Thank you. Well, okay, where do you take 37 and 38, Dave?
37 I took at Mission College,
Mission, okay.
and then 38 I took at West LA.
West LA, okay, good. They are both with, yeah, West LA is Los Angeles Community College District, right? So Mission College is also Los Angeles Community College, right?
Yeah.
District, right?
Yeah. Mhm.
West LA. Okay. Do you have access to Wiley Plus?
I don't.
Okay. What about any other platform that you purchased previously?
I don't think, I think everything expired.
Expired. Okay.
Yeah.
That's good. That's good to know. Gabriela Montes, are you there, Gabriela? Thank you very much, Dave. Let's move on to Gabriela. Is Gabriela here? I don't see Gabriela. Okay, next, Colin Newman. Colin Newman. No Colin Newman. Daniel Nwabu.
Yeah.
Okay, good. So, okay, so what can you tell me about your previous courses, Daniel?
I took it with Professor Gambo.
Gambo, okay, good.
Both. Yeah.
Both?
Yeah.
Okay. Okay, so, and Wiley Plus Access, do you have Wiley Plus Access?
No, they're all expired.
No, expired. And okay, you don't have access to any other platform, right?
Yeah.
Okay, good. And then we have, okay, thank you very much, Daniel. I guess you have your brother here, right? David Nwagbo, are you there, Dave?
Yeah, I'm here.
Okay, good. So did you take 37 and 38 as well?
Yeah, I took them with Gambo at LASC.
Okay, good. And I presume you don't have access to Wiley Plus nor any other platform, is that right?
Yeah, we use Beyond Labs and yeah, but Wiley Plus is expired now.
Okay, use Beyond Lab. Okay, good. Thank you very much. And let's go to Claire. Yeah, Claire is here, right? Good.
Yes, hello.
Hello, how are you doing, Claire?
Good. I took it also at UCSC.
UCSC as well? Okay. UCSC, both Physics 37 and Physics 38?
Yeah.
Okay. Wiley Plus access?
No.
Okay. Any other platform access?
No.
Okay, that's good. Thank you very much, Claire. Let's go to Angela now. Angela, I don't see Angela listed here. Yep, I don't think she's here. Good. Maria Raju. Are you there? Yeah, I don't see Maria listed either. Okay, Jennifer Ramirez. Jennifer. Yep, Jennifer is here. Okay, thank you, Jennifer. So where did you take Physics 37 and Physics 38? Jennifer? West LA? Okay, West LA. It's nearby where I live, West LA. You know, I was trying to get a job with them so I can drive just 15 minutes. Okay, so do you have access to Wiley Plus? No, okay. Access to any other platforms? Jennifer, no, okay, that's good. And thank you very much, Jennifer. Let's move on to another student. One more coming. That's Noah Raymond.
Good morning, Professor.
Good morning. Okay. So where did you take Physics 37? And if you took Physics 38, where was that?
UC Berkeley.
Oh, okay, UC Berkeley. Good. So you're just both of them, right?
Yes.
Okay. So you're taking the summer, take advantage of the summer to finish your physics courses, right?
Yes.
Okay, good. That's a very well-regarded school, UC Berkeley. Okay, so And Wiley Plus Access, do we have Wiley Plus Access?
No.
No. What about access to any other platform?
Also no.
No. Okay, that's good. Good to know. Thank you very much, Noah. Let me move on to George. George Risk.
Hi, Professor. Good morning.
Good morning. So where do you take Physics 37 and Physics 38, George?
I take both of them at Santa Monica Community College,
Oh,
SMC.
Santa Monica. Okay, Santa Monica College. Good. While you have Wiley Plus access?
No.
Okay. Access to any other platforms?
No as well.
Good. That's good. Thank you very much. Let's move on to Shah Safi.
Good morning, Professor.
Good morning, Shah.
I took Physics 101 at ELAC, East Los Angeles College.
It's Los Angeles, okay.
And Physics 102 at Los Angeles City College.
Los Angeles City College. Okay, good. Both
And I
at
don't
LA
have
Community.
access to any of those
Oh,
websites.
that's great. Thank you very much. Natalie,
Good morning.
good morning.
I took it
Yeah.
at West LA, both Physics 37 and 38,
Good.
and I don't have none of that.
No, okay, that's good. And thank you very much, Natalie. Let's move on to Nathan. Nathan Silva. I don't see Nathan here, right? Eliana. I'll be waiting list. Okay. Okay. I'll get to you, Elena, right? Let me see. Yeah, that's right. You're listed here in my waiting list. Yeah, see, I have waiting list of students here. So I'll get to the waiting list of students later on, okay? So let's see. Nathan is not here, right? What time? 8:35. I usually like to have a break, like we start at 8 o'clock and we have a break, let's say around 9:15, for 10, 15 minutes, so you can, recover. Staying sitting here for more than 1 hour is not very productive, right? We start to get tired. So, by 9:15, we take a break, 10, 15 minutes break, and get some water or whatever it is, so we can recover from doing all this hard work here. For instance, I'm starting to get thirsty. Okay, so let's see. Darnis Simon, are you there?
I'm here.
Okay, thank you, Darnis. So what's your situation about Physics 37 and 38?
I took them at Chico State. I'm just here to finish up this physics class and get my degree.
Okay, but you took Physics 38 as well? Electricity and magnetism? Okay, that's good. Both as Chico. While Plus access or any other platform access?
No.
No, okay, that's good. That's good. So thank you very much, Darnis. Let's move to Caddy Sobi. Let's see, I don't see listed here. Okay, yeah, so Aidan Tadeo, no. Lots of students didn't come today. Sandra Valencia.
Here.
Okay, hang in there. Let me admit these students first, Sandra. Let me see, here you go. Nathan Seal. Okay, Sandra Valencia. Okay, so Sandra, where did you take Physics 37?
Both at West LA.
West LA. Okay. Oh, lots of West LA students here. Okay. Wiley Plus access?
No, and no.
No and no. Okay, good. Yeah. I used to have a colleague from California State University, Dominguez Hill. He got a job there at West LA. I believe he's teaching there. I forgot his name. He is originally from Africa. Did you take the course with him, Sandra?
Professor Taye or something like that?
Taye, yeah, that's his name. Yeah, from Ethiopia, right?
Yeah, I did.
Yeah. Okay. He's a full timer there. Yeah, we used to talk a lot. We used to share an office there, and then he got this full-time job at West LA. I presume that's the only full-time instructor in physics there, right? I presume he's the only one in physics. Maybe.
There's also Professor Bell.
Bill? And he teaches physics as well?
Yes.
Okay. Okay, good. Thank you. So Lawrence is here now. I'll get back to him. Okay, Lawrence. Well, I'll talk to him later on. Kenny Villagomez, are you there, Kenny?
Good morning, Professor.
Good morning. So you took with me, right? Both physics 37 and 38?
Yeah.
You have no while plus access, I presume, right?
No.
And did your web sign expired or you still have it?
Yeah, I just bought it for 38.
Okay, and it's still good for the summer?
No, it expired.
It expired. Okay, good.
Yeah.
Thank you. That's all I want to know. Thank you. Robert Wall, are you there? Robert. I see Robert Falk, but no Robert Wall. Good. Nolan Williams, are you there, Nolan?
Hello?
Yeah, I see Nolan.
Hello?
No. Let's see here. Yeah, you're there. Good. I can hardly hear you, Nolan. So let me see.
Hello, Prof.
Oh yeah, hi. How are you doing? Okay, now I can hear you.
Prof, this is Lawrence Flores.
Okay, I'll get back to you. Let me finish here. Yeah. So what about Nolan? Nolan, I cannot hear you. Okay. I'll fix my mic. Okay, good. Okay, so just type there in the chat box, Nolan, since you're having problems with your mic. You took physics 37, physics 38 with me, right? Okay, and what about Wiley plus access? No. Do we still have access to WebAssign or is it expired? Expired, right? Okay, thank you. Thank you very much, Nolan. Mengshu Zhang, are you there?
Yep. Good morning, Professor.
Good morning. So where do you take physics 37 and physics 38, Meng?
I took it at Irvine Valley.
Oh, Irvine Valley College. Okay. Okay, both.
And I don't have access to Wiley Plus and the other platforms yet.
Okay, that's good. That's good to know. Okay, let me go back to Lawrence, right? Lawrence Flores before we get into the
Yes, sir.
Let me go here.
Prof, I just
Prof, yeah, you're breaking up. Let's see, Lawrence. Yeah, it doesn't look like you have a good mic.
I'm having problems. I'm having problems with my Wi-Fi. And my Wi-Fi company won't come in until next week because they're so packed with people having. I think somebody hit a pole near my house, and they're having a lot of issues trying to fix it. I just want to let you know that I'll do the best that I can to follow up with because I'm actually not home right now. I'm over here at a cafe trying to get the Wi-Fi, but it's pretty bad over here. And so I'm just trying to do the best that I can, but I just wanted to hopefully do the best that I can. I think they said next week they're gonna come by and fix it. So I'll do the best that I can. Maybe a friend can email me all the stuff that we're doing and I can go over it. And I just, I don't want to be dropped from the class because I really need it, but it wasn't my fault what happened, and I just wanted to make sure that I get that cleared, and hopefully I don't want to get dropped. And but they said by next week they should have it fixed. So I'm hoping that they do.
Okay. So just a suggestion, your cell phones, they have your Wi-Fi access as well. You might want to use the hotspot of your Wi-Fi cell phone. Okay.
I'm trying that, Prof, but I have a pretty bad plan on my Wi-Fi. That's why I was like, because I come from a low-income family, and so I can only afford, you know what I mean, Prof. And and so that's why I'm just doing the best that I can. I got lucky right now, and there's nobody here, but the people are coming in like crazy. So I'm just trying to, because everybody's around the area is having trouble with their Wi-Fi. So everybody, it's just crowded. It's crowded, and so. Prof, I just want to let you know, I'm doing the best that I can, and I'll do the exams the best that I can. If for any reason I can't take it that day, maybe how many exams are we gonna have, Prof?
Well, it's gonna be similar. There's gonna be 3 partial exams and 1 final.
Okay, Prof. So if anything, if for some reason I can't take it or I have trouble, is that okay? That would be my drop test, the first
Well,
one.
we can talk about that offline. Offline, we can talk about that. Let's talk about that offline.
Because Prof, I come in and out with my Wi-Fi and I'm having trouble, and it's like, oh man, I'm having a hard time, and my phone where I'm at, the area I'm at, the service is bad, so I'm like, oh man, so I'm doing the best that I can. I'm having a hard time, but I'm doing the best that I can, and I just wanted to let you know, update what's going on with my problem.
Okay. So thank you for sharing that with me. Do you have access to Wiley Plus? You don't have access to Wiley Plus, right?
No, I don't.
Okay. Do you still have access to
Like
it?
like I said, Prof, if it's okay, I'll tell one of my classmates. I know some of my classmates are on there. I'll ask him to send me like some of his notes. That way I can copy it, and then we can go back and forth. Because he lives close by me, so I'll ask him to pass me the notes, and that way I'm not so lost of what's going on.
Okay. Again, we can, let's talk about that later on too. Thank you for your input here. Let's go to the waiting list students now, right? So Ryan, are you there, Ryan? Ryan McNeil. Yeah, I see Ryan McNeil here. Oh yeah, you took, good, Ryan, you took the lab with me, right? And you took Physics 37 with Brian, right? At LA Harbor. Is that right? Oh, Crawford, you took his Crawford. Okay. Yeah, that's right. I'm mixing up. Good. And did you take Physics 38? I don't think you took Physics 38, right? Just confirm that with me, please. No. Okay, good. Do you have access to Wiley Plus platform? No. Access to any other web assigned for this semester? Any other platform for this semester? Okay, good. Elaine Boshard, are you there? Elaine Mary?
Hi, Professor.
Hi, how are you doing? Okay, so what's your situation about Physics 30F, 37, 38, Elaine?
I took them both at UC Berkeley.
UC Berkeley, okay, UC Berkeley. That's great. Wiley Plus access?
No, not yet.
Okay, what about access to any other platform?
No.
Okay, good. Yeah, thank you very much. So let's move on to Key. So, are you there, Key? No, I don't see Key listed here. Okay, Olivia Song, are you there?
Hello, Professor.
Hi, how are you doing?
Good, thank you.
Okay, so what can you tell me about Physics 37 and Physics 38?
I took 37 in Fullerton College, but I haven't took 38 yet.
Okay, you mean West LA College, you said?
No, Fullerton College.
Fullerton, okay. Fullerton, and no. Okay, good. Wiley access? Do you have Wiley Plus access? No.
No and no.
Good. Access to any other platforms? No.
Yes.
Okay, thank you very much, Olivia. So let's see, Sarina Lobana. I think I see Sarina. Yeah, Alina is here,
Hi.
right? Good. How are you doing? Okay, where did you? Yeah, did you take physics? That's definitely you took Physics 37, right? And where did you take Physics 37?
I took 37 at Moorpark College, and I took 38 at USC.
USC. Wow. Okay. Thank you. And what about Wiley Plus access? Do you have Wiley Plus access or any other platform? Access to any other platform?
No and no. And I also don't have access to Canvas for some reason. I always get an error whenever I try to log in.
Really? Is it because you are on the waiting list, maybe?
I'm not sure.
Yeah. Okay. Any other students are having problems accessing Canvas? Whoever is
I have access to Canvas either.
Yeah, type that in the chat box so I know who is that, please. Who is having problems accessing Canvas? I don't have access to Canvas either. Olivia. It must be because you're in the waiting list, Olivia. Let's see, Canvas access. That's a good question to have it. So let me put it here. Canvas access. Olivia doesn't have it. So I'm suspecting that because, what about Ryan? Do you have access to Canvas, Ryan?
Yeah.
Since you're in the, oh, you have access to Canvas. So, okay, so being the waiting list doesn't look like it's the problem. I'll get to you, Nathan, hang in there. Elena, are you having problems accessing Canvas?
I was having problems, and then actually once I got off, they let me in.
Okay. So you just log off and then you logged in back and you were able to log in. Is that right?
No, like once I got off the waiting list, then they let me. Yeah.
Okay, so you're no longer in the waiting list. Is that what you're telling me?
Yeah, I got off this morning, I think.
Okay, and now you are okay. Nice to know. So it looks like some students dropped, right? Let me put it to here. But okay, but what about your case? Ryan said he's having access. Okay, try Olivia and Sarina. Try to have access, again later on. And let's see. I presume everybody else is having access to Canvas, right? I'm presuming everybody else is having access to Canvas. If I don't hear otherwise from you, I will assume that you're having no problems accessing Canvas. Now let's see. Nathan.
Professor, I'm here.
Yeah,
Zachary Blue.
Zachary Blue. Okay, let me see here. Well, okay, Zachary. Okay, Zachary. Okay, where did you take Physics 37, Zachary?
At Southwest.
Southwest.
I took it last semester.
Okay, with Brian, right? Brian Gamble?
Yeah.
Okay. Did you take Physics 38 as well?
Oh, for 37, I took that at Bakersfield College, and 38 I took last semester with Brian.
Okay. Which college did you take for 37? Victorville, said?
Bakersfield College.
Bakersfield. Wow, Bakersfield. That's a long way. Okay, I have been there before. Okay, nearby Fresno, right?
Yes.
Yeah. Why do you have access to Wiley Plus?
Yes.
You do have access to Wiley Plus. You already purchased for the summer, right?
Yes.
Okay. What about, okay, so it doesn't apply. There is one more student here. Alex, do you have access? Do you have any more space available? Cannot even enroll. Wait, this is the permission number. Okay, I'll keep you in mind here, Alexis. Let me see. Let's put it here, Nigre. Alexis. And oh, Alexis, where did you take Physics 37?
I took both of them with you.
Okay, yeah, I didn't hear you. You took both of them? Where?
I took 37 and 38 both with you.
Ah, with me. Okay, yeah, okay, thank you. Yeah, you're right. Yeah, no, came back to me. Do you have access to it, Wiley Plus?
Negative on both.
Okay, good, thank you. Do you have any problems logging into Canvas right now?
Well, yeah, I can't even get on the wait list. That's all.
Yeah, that's right. Since you cannot even get in the waiting list, you won't be able to get into Canvas. Okay. Yeah, so it looks like this lack of access to Canvas is because you're in the waiting list. Okay. That with the exception of Ryan, right?
Professor, I'm also enrolled in the course.
Who is that?
Ryan.
Oh, you're enrolled, so you're no longer in the waiting list, Ryan. That's what
No.
you're telling me. Okay, so you must have get out of the waiting list this morning, right? McNeil, let me put it here, and then I will check that. Okay, now let's see how many students we have the total here. Anybody else that I didn't call? Let me see. Natalie, okay. Okay, we have Natalie. Let me see if I can. 30 so far, 29. Okay, let's see. Let's talk to Natalie. Natalie, let me see here. Natalie Santiago. You're here. Okay, I already talked to her. Okay, anybody else? 30. Good, so it's 52 right now. Let's have our little break. Okay, and go ahead, stand up, stretch a little bit, drink some water or anything else, right? Zach Blue. Let's see, I already talked to Zach. Yep. Already talked to Zach. Okay, looks like I talked to everybody that's present. Good. So let's take our little break now. It's 8:53. Let's do our break until 9:05. Okay, 9:05, just a little bit more than 10 minutes. And I see you shortly. And by the way, for those who are trying to add, just hang in there for the next few days, okay? I want to make sure that the other students that are registered didn't, are not attending, and then I can start distributing ad codes, okay? So I see you shortly in 10 minutes. Okay, I'm back here. And let me start sharing here my screen again. 38, 39. No, that's not the one. Okay. Here you go. Here's my syllabus. Okay, and here's the Zoom link for the course. So we'll be using Halliday and Resnick, Fundamentals of Physics, 12th edition, and you can purchase access through Wiley Plus for the ebook, and also the homework is $69. Let me share the. You are going to need, I'm going to post this flyer there in Canvas. You're going to need this book course section ID, okay? B86763. Let's put that here. Okay. Use the following book access. Course section ID. The following course section, section ID. B867. Oops. 86763. Okay, I also have my own physics notes if you want to. It's not requirement, but if you want to learn a little bit more about this course, that's a type of notes that I have been developing for several years. There are lots of things in there that you're not going to find in regular books. You can purchase that from Amazon.com. I broke it down into two volumes, volume 4 and 5. That's the link for that. Homework, homework problems, you will need access to Wiley Plus, right? Wiley Plus online. And I'm going to repeat this course section ID here. Course section ID. I used to use WebAssign, but WebAssign is more expensive. But just recently, Brian told me that that Wiley Plus is it's cheaper, $69 only. Log into Wiley Plus, and here you go. That's the link. Wiley Plus. I hate that. Let's see. Let's do it this way, and I will. Okay, so let me. I'll do that myself. If you're not ready to buy it yet, you can buy later on. Okay, so don't be in a hurry. But at least you're gonna have a 14-day trial for this. Go Wiley Plus. Here you go. That's the course. Okay. Physics 39. I already put my the first homework in there, and let's take a look at the resources here. Textbook. what I'm going to do, I'm going to cover some specific chapters depending on the with whom you took the course. Okay, maybe you already have seen some of the chapters, but what I'm gonna do what we do there at LA Harbor. I have several students of my course that took the course with me, and what we're going to do, we're going to start with oscillations, wave 1 and wave 2. Okay, that's how I usually teach this course. So here you go. Chapter 15, okay, oscillation, wave 1 and wave 2, 16 and 7. Let's see here. I'm going to, I will work the schedule for until next time. But what I want to do here, topics, right? Topics for the semester. Let's put it here. Topics for the semester. We start with oscillations, chapter 15. Oscillations. Chapter 16, wave 1. Chapter 17. Wave 2. Okay. And then we have a special type of wave that we call electromagnetic waves. That we're going to skip all those chapters, with thermodynamics, kinetic theory of gases, and then we're going to go to chapter 33, electromagnetic waves. It's a special type of wave, and before we start to talk about it, not only special, but it's very important, electromagnetic waves. That's why we cover waves first. And before we cover waves, we have to talk about oscillations as well, because waves are generated, we can state that waves are generated by oscillations. Okay, talk for this semester, topic for the summer session. Okay, and then we get into geometric optics, interference, diffraction, and then here you go. Let's there will be sound waves in there, a special type of waves as well. Okay, superposition of waves, and here you go. 34, chapter 34. That's going to be geometric optics. Call it images. This book call it images, but it's actually geometric optics here. That's this chapter on learning objectives. Here you go. That's why we start optics. And then we're going to get into chapter 35. Okay, light as a wave. Interference of light is a very important topic as well. It has lots of practical applications. 35, interference. Light as a wave. Then we're going to cover diffraction. Diffraction. And when we finish this part here, that's what we call classical physics. Everything that we have here is part of a classical physics. Classical physics. The physics that was developed before the beginning of the 20th century. Before the 20th century. Okay. And then from now on, is that going to be modern physics? The physics of the 20th century. And then that's where you're going to start hearing about that famous guy, that famous physicist that developed two important theories, at least two important theories, which is one of them was the special relativity. That's going to be chapter 37, which was Albert Einstein. So chapter 37, special relativity, by Einstein. Made major contributions as a free textbook. Okay. And then here starts quantum mechanics. Okay, photons and matter waves, chapter 38. Matter waves. More about matter waves, chapter 39. Let's take a look at this chapter quickly here. Here you go. More about matter waves. Okay, here you go. That's basically what it is quantum mechanics. And we are going to solve some problems related to quantum mechanics that involves differential equation. And I usually finish right in here on chapter 40 when I take this course, when I teach this course. We don't have enough time to get into nuclear physics. Okay, all about atoms. All about atoms. Atomic theory. That's all about. But if we have time, we are going to move on to the other topics as well. But at least, we are going to cover at least those topics that you see right in here. Okay, oscillations, waves 1, wave 2, electromagnetic waves, images, geometric optics. Here, what you see right here is the part of optics. I'm going to put it here, optics. Okay. It's still part of classical physics, okay? If I were to organize that, I would write that like that. Optics is part of classical physics. And then that's when we finish diffraction, that's when we start with modern physics. That's the organization of the course for this semester, for this session, for this summer session. Okay, and I will organize this one better, okay, and I will post there in Canvas. That's access to Wiley Plus. Okay, office hours. How are we going to do office hours? I haven't decided yet, but the office hours is going to be, just bear with me. I will provide you with the date and time for my office hours. Office hours will be through this Zoom link. Okay. More on that in the next few days. Okay, next few days, next couple of days. the next couple of days. Prerequisite is Physics 37 and Math 265 are equivalent with grade C or better. Okay, and physics notes. When I mean about ebooks, I'm talking about my ebooks, okay? Okay, every now and if you purchase my ebooks, every now and then I update my own ebooks with new and additional information. Every time a new version is uploaded, you'll be able to update it for free, okay? Please contact Amazon.com for updated instructions. Grades are based on attendance, lab report, homework, partial exam, and the final exam. Attendance is required during all labs. Make sure you have reliable internet connection. The instructor, I will maintain an attendance record during the summer session. Will you be posting syllabus? Yes, I'll be posting syllabus on Canvas. Yeah, I will. Okay. It's when I finalize that, I will post it. Okay. So bear with me, and homework is performed and submitted online using Wiley Plus. And grades. Homework accounts for 10% of the final grade. Subscribing to Wiley Plus is a requirement for the homework. Partial exam, there will be 3 partial exams. I'll drop the lowest grade of these exams and we'll take the average of the remaining 2 exams. This average accounts for, I'm going, let's see how I'm gonna do it. Yeah, I'll keep 50%. We'll account for 50% of the final grade. All partial exams, the date of the partial exam will be announced soon, okay? And will be during the time allotted for the lab. And what's the time allotted for the lab? Let's go get it. Yeah, think of summer class schedule. We go right in here, physics. Okay, so I'm gonna document that in the syllabus as well. See here, the lecture is from 8 to 11:30, and the lab is from 11:30 to 2. So let's schedule here. Textbooks, physics, class meeting. Let's see. Class schedules. Lecture and lab. Let's see. Lecture Monday, Tuesday, Wednesday, and Thursday from 8 a.m. to 11:30 a.m. Lab Monday, Tuesday, Wednesday, Thursday from 11:30 a.m. to 2 p.m. online. So the exam is going to be during this time slot. 3 hours and a half of lecture, 2 hours and a half of lab. Yes, we're going to have a break, We're going to have a break so we can relax a little bit, right? I'm still deciding what to do, It's the way that they set up in there is like from 8 to 2 p.m. the whole day. It's not reasonable, right? We still have to have lunch. So I'm thinking about putting a slot of half an hour for for lunch from 11:30 to 12 noon. Okay. And I'll keep you posted as we go along. Anthony Lopes. Let's see. Anthony Lopez. Yeah, okay, you are here. Three partial exams. I will drop the lowest grade of these exams and I'll take the average of the remaining two exams. This average accounts for 50% of the final grade. The date of the partial exam will be announced soon, and we'll be doing the time allotted for the lab. Okay, so we are not going to, you don't have to worry about that. Final exam. Final exam includes all material covered and accounts for 20% of your final grades. Make sure you take the final exam. If you don't take the final exam, you're going to get an F for the whole course. Last final exam will take place on the last day of class. Here's a little table. Attendance, you're going to get a little bit of a attendance grade for the attendance, 5%. Lab work, you know, it's going to be a virtual lab. So I'm going to put it between quotes. I'll talk more about that. Homework, 10%. Partial exams, 50%. Final exams, 20%. You sum everything, you get 100%. Arrive before the exam starts or will not be allowed. And by the way, here you go. I got to put more information here about the partial exams, okay? Partial exams will all, and let's see. I'm going to put somewhere else, elsewhere. Here you go. I'm going to write that down here. All exams will take place using Canvas. Okay. You must be logged into Canvas and into this Zoom link with your webcam on. Make sure you have a webcam, whether a cell phone webcam or a computer webcam. Oh yes, you know, for the lab you must be, yeah. Let's see, the way I do it. So Toby is asking if the grade for the lab includes attendance. The way I do, Toby, just by attending the lab, you know, being there on the spot, you're gonna get 20% of the grade of the lab, right? If you don't turn in your lab report, then you get only 20%. If you turn in your lab report, you can get up to 100% in the grade. That's attendance, homework. Let's see here. At the day of exams, exam will take place on Canvas. You must be logged in on Canvas and into this Zoom link with your webcam on. Okay. The Zoom link that I'm talking about is this one here. Let's see, where did I put it? Not yet, Pedro. I don't have the dates yet, but I will get that to you soon. So I don't have the dates of the exam yet, but I will announce them soon, okay? Webcam Zoom, the Zoom link into the class Zoom link with your webcam on. Arrive before the exam starts, or you'll not be allowed to take okay, exams are open notes, open book. Open book. But you cannot get any outside help whatsoever. Any other outside help whatsoever. Okay. Academic and scientific misconduct are problems in today's society. And this problem has been, which has been cleared, acknowledged by several government agencies. They have happened in the past, and with the advent of computers and the internet has become far easier and tempting to perpetrate. Okay, unfortunately, this problem is not restricted only to the student population, but also to professionals, professors, and researchers in the private sector, government, and academic institutions. So let's, today, let's put our problems today. So keep in mind that academic scientific misconduct is not restricted only to the student population, but also to professionals, okay? Once you go out there in the real world, you're going to, unfortunately, you're going to find people like that try to take a shortcut, okay? Plagiarism is just one form of academic misconduct. Every year, agencies throughout the world unknowingly fund research that duplicates someone else's work without proper attribution of reference. Okay, that's a problem that I myself have been having throughout the years. There are researchers out there that are plagiarizing my work, and they are not providing proper attribution of my previous work. And I have done work back in the 90s, 1990s, that people are not attributing, and they are claiming that work is theirs. Okay, and the interesting thing is that I have the patents for that work that they are plagiarizing, and I'm gonna go after those guys. So plagiarism is one type of academic misconduct. Okay, plagiarism. I'm gonna put it here: plagiarism and data manufacturing. Data manufacturing is another. Plagiarism usually occurs whenever someone wants to get a grant, get money from the government. They know of previous work that was done, and there are historical evidence that many researchers have done that. They know of previous work that was done by someone else, and they don't attribute that work of someone else because they want to get money from the research agency. If they cite someone else's work as previous that preceded theirs, the government is not going to fund their work. So they withhold that information, and basically they plagiarize someone else's work. And then there is this more serious type of misconduct that's called data manufacturing. Data manufacturing in experiments. That's another type of misconduct. They claim that they perform the experiments, they make up the data to make the data look good, submit to the agency to get money, and they get money. It happens, unfortunately. Okay, every year workshops are held throughout the world to discuss these problems in order to prevent and deal with them. Unfortunately, it's very likely that after you graduate, you will witness either type of behavior in your professional life. During this course, you're supposed to generate your own data. Well, we are not going to generate our own data because we are going to do, I'm going to provide you with the data. Those are virtual labs with your group member and report it accordingly. Data must not be copied or plagiarized from other groups or manufactured into your final report. For this reason, your report will be carefully corrected to determine that there is any plagiarism or data manufacturing. Okay. For more on academic integrity and plagiarism, consult the university catalogs and articles published in the internet. There must be a little, let's see here, lab work. I'm gonna put a little thing about labs here. Bear with me. Here you go. That's what it goes. Great. Okay, for the lab. Yeah, I gotta introduce this. Okay, physics notes, lab notes. I'm gonna put it here. Something that I didn't cite it. In addition to my physics notes, I also have my own lab notes. Okay, here you go, lab notes. Lab notes. I developed a series of experiments, oscillation waves, and modern physics, experiments in physics by myself. Here you go, this is a lab manual, can be purchased. So I have both physics notes for the lecture and lab notes as well. They're not requirements, but it's nice if you want to learn a little bit more about the experiments that we're performing. Okay, that's and then I gotta put online lab activities. Final exam. Let's see. I'm gonna put it. I have to put it. I'm gonna put it right in here. Here you go. Lab activities. Online due to the. Okay. During the summer session, there will be no hands-on experiments. Instead, the instructor will provide you with actual data obtained from previous experiments by other students. And you will work with this data to display it in the proper format. Yeah, see below. Okay. Okay, so here we go. Laboratory work. Lab work is an important, due to the nature, okay, due to the nature of this online course, there will be no hands-on experiments. Instead, the instructor will provide you with actual data obtained from previous experiments by other students, and you will work with this data to display in the proper format, plot graphs, plot graphs, etc. So laboratory work is an important component of any science. So for this reason, we design a series of 10 experiments for this course to reinforce the concepts presented during the lectures, demonstrating in practice the concept taught, familiarize the students with various types of equipment available for engineering and research purposes. So we're going to be talking about some of this equipment, demonstrate lab procedures and methods of data analysis, learn techniques to troubleshoot an experiment and your data. So that's what we do in an actual experiment. If you took the lab experiments with me, oftentimes you would get data that was not consistent with what we would expect from the experiment. So we'd go through the troubleshooting of what we did. And in the process of troubleshooting, we discover, I usually discover that the student didn't perform the experiment properly, right? In our experiment, you'll be working with no more than 2 classmates. You can choose your classmates. However, the instructor reserves the right to change your group, okay? Lab report, there'll be a lab report. Okay, so here you go. I'm gonna copy and paste what I have here from the previous courses. Here you go. lab report. Each group will submit a single hard copy report and an Excel spreadsheet containing the data. Yeah, I provide you an Excel spreadsheet containing the data, results. Let's see, each group will submit a single hard copy report and an Excel spreadsheet. Here you go. The spreadsheet contains the data, results, the data and results required to plot your graphs, if any. To plot graphs, if any. Sometimes there are for the experiment, for the virtual experiment, this virtual experiment. Okay, these documents must, well, because we're in a compressed semester, right? It's going to be a little bit different. These documents must be turned in not a week later, but will be turned in the date announced by the instructor. Announced by the instructor. Let's put it this way. This is a very compressed semester, right? And so the spreadsheet contains the results required to plot the graph. The instructor will provide you with the Excel spreadsheet with your data. The spreadsheet will be put in your group folder. In a group folder that will be created by the instructor. Okay, we're going to get there. So bear with me for now. If you already took the lab with me, you already know how I do business, right? Our group members must contribute to the preparation of the lab report. In order to ensure the contribution of every group member, I advise, although this is not a requirement, that each group draft a sample agreement in writing, committing each of their members to contribute to the write-up of the final lab report. Okay, your lab report is worth 100 points, and your grade will be based on the following. Here you go. The way I do my labs, you have to report every measurement in terms of the main SI units. Here you go. I'm going to put in bold face. Oh, I'm going to put that in bold face. Here you go. And what are the main SI units? Meter, kilogram, second, Kelvin, coulomb, mole, and candela. We're not going to do candela. We're not going to do measurements of light intensity, okay? But that's what the main SI units are all about. There's a total of 7 main SI units. They are independent of any unit out there. I like to tell my students, right, that there are some basic core concepts in physics. That physics starts from very few concepts out there, and I'm going to brief you on that in case you haven't taken my course in the past. Those 7 units are in every possible combination of them, you will not report your units in centimeters, millimeters, gram, milligrams, hour, minute, etc. Okay, here you go. This one doesn't apply because I will provide you the data, right? So it's stricken out. I'm not going to take it out. I'm just going to leave in there just to remind you that this item applies to actual experiments. The correct number of significant figures, okay? Be based on the following: proper SI units, correct number of significant figures. For each missing significant figures, I will subtract 0.2 to 0.8 points for your lab report grades. On the other hand, for each significant figure that's added incorrectly, I will subtract 0.1 to 0.4 points from your grade. The exact number of points subtract will depend on the lab report. Use of proper units in the report. For every missing or incorrect unit, I'll subtract 2 to 3 points. It's very common for the students not put the units of their measurement. It's a requirement of any report, whether you're doing here for this course or whether you're doing it in a professional manner. Proper format of the lab report. No neatness, completeness, and accuracy. There is more about the proper format, and we're going to talk about that. Reporting of proper statistical results of the proper, let's see. Of proper statistical results, let's put it this way, such as a percentage difference, very important, average, standard deviation from the mean, regression curve, determination coefficient, confidence level, and others. Those are all statistical concepts that you are supposed to report. Graphs, if any. The graph must be clean and planned to optimize its space, no large blank areas in the graph. If you publish professionally, again, whether it's a paper or a report to your boss, there will be, most likely there will be a graph in there. Let's see, any questions so far? Am I going too fast here? So let's see, we have 32 students. I believe we had 2 more that just joined us, maybe 3. Who has just joined us right now?
Me.
Okay, Harun, right? Let's see here. That's 9:40 right now, Harun. Okay, Harun Atif. Okay, I'm gonna give you half for the lecture. Okay, Harun. And what about Musa, right? Musa and Harun, right? Musa, are you there?
Yeah, I'm here.
Okay, okay. So you both took Physics 37 and Physics 38 with me, right?
Yeah.
Okay, do you have Wiley Plus access? We're going to be using Wiley Plus. We're not going to be using WebAssign this semester, okay? I presume you do not have Wiley Plus access yet, right? But you should purchase it. Do you have access to other platforms that you're still using right now? Musa and Harun?
Yeah.
Okay, you use it in the past, but we still have a valid access code for WebAssign, Harun.
I don't think.
You don't think so, right? No. Yeah, let me know. Check that, okay? And if you have, let me know. We're gonna meet. We can meet about that. Let's see, 130, 132. Okay, it looks like we have one more student that came in later, right? Just now. Who is that? Antonio Lopez. Okay, who was there? Well, whoever it is Daniel Liang. Oh, you just joined. Okay, Daniel Liang. Let me see here. Daniel Liang. Okay, right in here. I'm gonna give you half of a credit because you arrived late. Okay. Now, why did I put that? Okay, who do you take Physics 37 and Physics 38 with, Daniel? SMC, okay, SMC, USC. Okay, do you have access to Wiley Plus, Daniel? No, do you have access to any other platform, homework platform? In addition to Wiley Plus, WebAssign or Master in Physics? I presume not, right? I don't hear your answer. No, okay, okay, good. Anybody else? Let's see, 35. Let me, I wanna get the exact number here. So I presume that another student joined us here. We have a total of 33. Yeah, we have one more student here who joined us right now. Yeah, let's see. Aiden, right? You just joined us, Aiden? Yeah, you just joined. Okay, so again, I'm gonna all those students make sure you arrive on time, right? Because we did lots of things up to now. You missed important information, and let me see, Aiden. Who did you take physics 37 and 38? Aiden? And the question is for you, Aiden. I took at UCD stands for? Oh, UC Davis, okay. UC Davis, okay. Both 37 and 38, is that right? Okay, well, do you have access to I Plus right now for the summer? No, okay. Okay, you need to purchase that, okay? If you want to do your homework, do you have access to any other homework platform out there, such as WebAssign or Master in Physics? Not at the moment. Okay, good. Thank you. So 32, good. So we have 34 students. Many of those that are registered didn't show up, right? So here we go. Let me save that one. Going back to the syllabus. 9:55. We're gonna have our break very soon. Let's see if we can finish the syllabus. Okay, so here you go, graph. You should know how to plot graphs. They must look very nice. They must be planned. You know, you're going to plot your graph in given, you're going to optimize the space of your graph. Okay, label the axis of the graph with their proper quantities and corresponding units. Ensure the numbers along the axis are properly spaced and not encroaching on each other. Do not connect each data point to straight lines. Instead, fit the best curve to this data, the best average, let's call it average curve. One more, Alex, okay, Alex. Average curve. There's a proper procedure to find this average curve, okay? And this can be done in Microsoft Excel. Here's a step-by-step, you know, I will walk you through how to do that. We'll do that today during the lab time. Okay, so you know how to plot it. At this point in time, you should already know, right? Because you're taking your third course in physics. At this point, you should at least, you know, let's see, at most, the third course in physics. I like to use Excel to do all those labs. And here's the instruction I'm going to walk you through later on. Attendance and participation to the online session accounts for 20% of your lab grade, whereas the remaining 80% comes from the correction of your lab report. Okay, you must be present. Here you go. You must be present for the lab. If you're present during the online meeting but fail to turn in a given report, your grade is going to be 20%. However, if you fail to attend an online meeting, your grade will be 0% for that specific meeting. If you turn in your hard copy report but fail to turn in your spreadsheet, you will get no more than 50% of your grade. Okay, so there are two parts for the lab report: a hard copy and a spreadsheet. And they must be uploaded to your group folder. I am planning for 10 labs. Maybe there will be less. Let's see how things goes. Okay. Anywhere between, you know, there was total, and let's not say 10 lab reports. There will be a total of 8 to 10 8 to 10 labs, lab activities, and their respective reports. How are you going to do the hard copy online? Okay, the hard copy online, you're gonna use the Word documents, right? You know, the hard, I'm not gonna talk about that. Let hang in there. Yes, that's right. The hard copy we printed, right? Well, that's why I use, let me see, that's why I use the quotes in there. Let me see, I guess I did that. Some hard copy, here you go. That's the right way of characterizing it. I like to, in an actual experiment, right? In the past, not an actual experiment, in the past, before the advent of computers, it was an actual hard copy, right? But then now with advent of computers and advances in technology, the hard copy became an electronic copy, and that's what I call a hard copy. Yeah, that's right. I mean a file, a Word file. A hard copy would be like a Word file, you know, a Word file in electronic format. Electronic format. That's okay. And the spreadsheet is just an Excel, you know, Excel file. Okay. Let's see how we're gonna do it. All labs reported to. No, it's not 1 week Word file. That's right. With a docx extension. Yeah, that's right. These let's see. All lab reports are doing. All lab reports are due. You know, the due date of the lab reports. The due date of the lab report will be announced by the instructor at an appropriate time. Okay. Here you go. There won't be any individual lab reports. I must try to implement that, but it didn't work very well. So that all the reports is gonna be group reports. Our reports will be group reports. Okay. At the end of the semester, I will drop the lowest grade of your reports and determine the average grades from the remaining ones. Okay, I will not the individual. Yeah, the last report will be due at the end of the lab meeting. At the end of the semester, we don't have time to, you know, to turn in the reports, right? So you prepare the last report you prepare during the experiment, and you turn it at the end of the meeting. Hard copy. Let's see. Let's put it here. The reports, you know, lab reports will be in 2 parts. Lab reports will be in 2 parts. You know, a hard copy one, which is a file in Word format, and a spreadsheet. In Excel format. Okay, so this should go at the beginning, right? Let me see here. Lab reports. Oh yeah, here you go. I already mentioned that. And let's put hard copy here in quotes so you don't get confused. Okay, the spreadsheet content. Yeah, this one goes there. Let's lab reports will be in 2 parts. Okay. Lab reports. A lab report. I'm going to put it this way here. Here you go. Your lab report Your lab report has two parts, you know, and a spreadsheet. Each group submit a single set of this report, Word plus Excel document. Okay, here you go. The spreadsheet contains the data and results required to plot graphs, if any, of your virtual experiments. The Word document, the document, the Word file is a document in the proper sense of a report. Okay, let's put this way here. Report. These two documents must be turned in the data announced by our instructor, by the instructor. At the beginning of the experiment, at the beginning, oops, what's that? At the beginning of the experiment, the instructor will provide you with an Excel spreadsheet with your data. Okay, so that's what, okay, lab report format. Lab report format. Your hard copy lab, okay, your hard copy lab report must be typewritten in Word format. I recommend you use Times New Roman font, size 12 or larger. Any departure from the document. Any departure the documented format will affect your final grade. The required information must appear in the following order: a title page, center justified and separate by one line, physics 39, lab number and title. Okay, I will provide you the lab number here in the syllabus, name of the students who performed the lab in alphabetical order by their family name, group number, date the experiment was performed. In the next page, prepare a table with the original data and any results. That's the format that I use in my courses. Okay, the table must be neat and well planned so the reader can easily grasp the data. Also include the proper units and sequence figures in this table. Graphs, if any, error analysis, answer to any questions when asked. Okay, so let's see if there is anything else here. Okay, laboratory bunch, okay. So this part here is the description of your Excel spreadsheet, right? What two hard copies, and the other one is just the description of the hard copy. Any more questions? So here you go. I talked about the misconduct and academic and scientific misconduct. Accommodation of disability. If you have a disability verified by the university, please notify me in advance so I can provide you with the proper accommodations. Make-up exam policy. There are no make-up exams. If a school function, religious holiday conflicts with an examination date, please notify the instructor at least 1 week in advance so he may reschedule the activity for the whole class. The student responsible to advise the instructor 1 week in advance of any school function or religious holiday. Okay, class conduct. That doesn't apply, right? But grading the total number of points. Let me see if there is anything. Total number of points. Let's see. Total number of points accumulated will determine your final grade in the course. Here's the scale that I use: A, B, C, D, and F. Okay, let me see if I'm missing anything else here. Yeah, that's what it is. Okay, and I will finish that later on, you know? So don't, you might want, let me see, I'm going to do the following. I'm going to delete this part here. Clear. Clear, 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 clear. There's no clear here. Huh. Interesting. Yeah, yeah. Okay, I'll have to adjust these dates, okay? So just to ignore for now. Clear, delete, merge, port. Man, it doesn't clear. Interesting. Let me see if I cut. Okay, good. That works. That works. I have to adjust here 16 and 17, right? If we go to the other, here you go. Wave 1, wave 2, and then we have electromagnetic wave. That's a special type of wave that was discovered in the mid of the 19th century, 1617. Electromagnetic waves, chapter 32, wave motion. Let's put it here. Let me take out sound waves for now. Okay. Wave motion 1 and 2. Let's see. I'm gonna put electromagnetic waves here as well. Let's see here. This one should go. Should go here. Below. Nope. Both, yeah. Now, put the short waves. Here you go. And then that's 33. Images, ray optics. Ray optics is / geometrical optics. 34. I do not know if we are going to have holiday yet, so bear with me. You know, 34, 34. Wave optics, okay, that should be 35. 35. Those numbers, those chapters that you see here is for the other book that I use. So 36. And then relativity is going to be chapter 37. 37. And then I will put some dates here for you. 37, let's see, 37, 38. Here you go, 38, 39, and that should be, you know, 40. Like that. It's going to be somewhat like that. I got to get you the actual date that you're going to do that. So I don't have it yet, but I will get it in the next few days. And I'm going to save this document in PDF file. Okay. Did I get it right here? Superposition. Yeah, it's not 7 wave motion. Let's put the wave motion 1. Here you go, 17. That's going to be wave motion 2. Okay. ENM, electromagnetic waves, wave optics. Oh, why did I put summer 2029? It's supposed to be 2022. It's not LA Harbor College, it's LA Southwest College. Southwest College. Yep. That's the first version. I'm gonna work out the details of the schedule, okay? and I will provide the date of the exam. But you should expect one exam every week and a half. 4 exams, 5 weeks, 5 divided by 4, a little bit less than 1 week and a half. Okay, exams you go. Fine exams. You should expect 1 exam for every 1.5 weeks. Our exam will be on Canvas. Must be logged into Canvas and into the Classroom link. You must be logged. Okay. Come on. What time is that? 10:15. Okay, we're running out here of time for our break, right? Any questions that let's see if I missed any questions here. What would be the time frame for the exams? Oh yeah, it's going to be 2 hours. I scheduled the exam for a 2-hour long exam. There'll be enough questions there for you to fill the 2-hour time frame. Save. Let's see here. Save as. And there should be version 1. Huh? Interesting. What the heck is going on? Wait a minute, something wrong here. This one here. Nope. Here you go. This one here. Am I missing it? No, that's not the one. What's going on here? Yeah, that's not the one. It looks like did I quit that document? Hey, wait a minute. Bear with me, please. It looks like I did something wrong here. Huh. Suddenly it disappeared. Is it possible that yeah, that's the one I'm talking about? Is that the one I'm talking about? Huh. That's not the one I want. Let's see. Lab. Huh. Did I lose all that hard work? What happened to it? Okay, well, looks like I need a break. Okay, I cannot find the document that I was working on, and let's take a break right now. And I'll figure that out before we meet again. It's 10:16 now. Let's break till 10:30, okay? 10:30 a.m. Any questions before you go into the break?
I do have a question. When can I talk to you about that message I sent you?
Let me see who is one minute. Let me.
I sent you a message at the beginning. David.
Dave. Let me see.
David Mays.
Let me check. Chat. Dave. Let's see. You send it through the chat.
Yeah, at the beginning of class.
At the beginning of the class, the very beginning of class. Let me see, Dave. Send me the message again. I cannot. Oh, okay. Is there any way to asynchronous? Okay. No. Look, yeah, I mentioned that at the beginning. Okay. This is a synchronous course. Everybody must be present during the synchronous course. Okay. Especially the lab. I'll be taking attendance. You should be interacting with the instructor. So you must be present at least during the lab portion. Okay, if you want to take a chance and not be present here during the lecture, it's fine. But remember, I'm giving you credit for attendance. But the lab, you must be present. Okay, so please figure out a way of being present at least during the lab. Okay.
Okay.
Okay, so let's okay, good. So let's have our break right now, and I'll see you in 15 minutes, 12 minutes. Okay. See you then. Cumulative. Oh, the exam cumulative. The final exam is cumulative. The partial exams is just those chapters that were covered during that part. Okay, Daniel? Only the final exam is cumulative. I will turn it off here. Okay, I'm back here and 10:30. Okay, so now we're going to be meeting until 11:30. We have 30, 40 students. That's good. By the way, I am going to share my screen here with you. Here you go. Check Canvas. I posted the syllabus in there. And then I also posted the instructions to set up your Wiley Plus account for the homework. Both are PDF documents. I also have an announcement here, right? I believe everybody saw this announcement here. Let's see, how do I check it? Why I cannot? Strange.
I think click physics 39 at the top.
Really? Let's
Yeah.
see. Yeah, okay, good. Thank you. Yeah. So everybody can see this announcement. Everybody who has access to Canvas will be able to see this announcement, right? I presume that those students that are still on the waiting list, it's uploaded. You can see it. Yeah, there is this announcement, and then there is those two documents. They are locked. Let me see. I believe it's published. Let me see. For me, it says that the file is part of unpublished module. Huh? Really? Anybody else is having a problem? I don't think you published. Yeah, isn't that strange? It's unpublished. Thank you for letting me know. Let's see what's going on here, how we can fix that unpublished. No, it says that it's published. Let's see.
Why don't you try, you see where it says physics 39?
Physics 39, yeah. Yeah, no.
Buttons on the side of the first one, just of the module. Maybe that's where it's unpublished, because I think the two documents are published, but the module is not.
Let's see, add module. Is that what it is? Let's see. How I'm going to do syllabus and other documents. Prerequisites. Let's see, add module. No, see, that's the modules here.
Professor, I think you're supposed to click on the you see right above the green check marks, there's this like cancel sign. Look above, and then right to the left of the plus sign.
Left of the plus sign.
Yeah, click that to publish
you're
it.
right. Yeah, you're right. Yeah, I was looking here. It says publish. Okay, so let's see.
Yep, that should be it.
Okay, that should be it. Yeah, it's so strange. It has this guy here grayed out saying that was published. Okay, so you should be able to access now, right? That's easy. Okay, I want to delete this one, right? Yeah, okay. Yeah, unpublished. Strange. Okay. Now, how is that? Everybody can see it now? Work it for you? Okay, good. Thank you. Amalia, good. Now, we have 3 students that are in the waiting list, right? Well, actually, 2 students in the waiting list. Alexis is still. Let's wait until tomorrow, okay, folks? Those of you who are trying to get in, you're welcome to participate today. Let's wait until tomorrow. Let's see how the other students that are registered, if they come or not, and then I start distributing the ad codes for you, okay?
Thank you.
Yeah, and let's see if I can. Okay. Let's save it here. Let's get the notes. Okay, I always, at the beginning of every course of mine, whether you took it or not, I like to share with you how physics is organized, okay? Because not every professor does that, how physics is organized. Okay. Or the building blocks of physics. Or the building blocks of physics. There you go. Building blocks of physics. So there are 3 building blocks. Physics has 3 building blocks. Three building blocks. So we start with those 3 concepts, okay? We don't have like 300 building blocks. We don't have 1,000 building blocks of physics. We have only 3. That's the beauty of science. We create very simple ideas at the beginning, and then we expand on those ideas. Okay, what are the 3 building blocks of physics? So you have the basic quantities. Okay. We have the primary definition. And then we have the laws of physics. I'm going to put that in table format so it's easy for you to understand. Here you go, basic quantities, primary definitions, and the laws of physics. You go right in here. There are 7 basic quantities. There are only 2 primary definitions. And then there's a number of laws of physics. There are 3 laws of mechanics, plus 4 laws of thermodynamics, plus 4 laws of electromagnetism. Those are the ones that you saw so far. Let's write it down. You know, 3 laws of, let's see. No, I'm gonna, you go like that. So far, there are more, okay? But so far, there are those 11 laws of physics that we have studied so far. Let's list out what those quantities are all about. First, the basic quantities. We're all familiar with them. Length. Okay. Think about the concept of length when it was invented. Those are inventions of the human mind, abstract concepts that we come up with to help us explain the world. Okay, and then another basic quantity is the quantity of time. Okay, the SI unit of length is the meter. The SI unit of main SI unit of time is the second. The next one that you have to know is the mass. The SI unit of mass is the kilogram. All those 3 concepts are supposed to be independent of each other. But then someone else called Einstein came along back in the beginning of the 20th century, and he discovered that those 3 quantities are not independent of each other. So all those concepts of basic quantities are related to classical physics. We still use them today, okay? But Einstein discovered that they are not independent of each other, but that's okay for now. That's okay for now. We don't want to complicate things. Maybe one day we're going to come up with better basic quantities, but let's stick to those three so far. Those seven so far. What are the other four? You know, we have quantity of a substance, amount of a substance, and that's the unit of the amount of substance. Thermodynamics, we introduced that in thermodynamics. Right here, we introduce those three mechanics. Okay. I'm going to put it this way. Let me organize it in a different way. Mechanics. Length, time, mass. And then in thermodynamics, have amount of a substance. Thermodynamics, we go. We have what else? E&M. We have this basic quantity in electricity and magnitude that has been known for a long time, by the way, has been known since ancient antiquity. The idea of electric charge. Okay. Those are all ideas that we create from scratch. The unit of electric charge is the coulomb. Oh my, here you go. 1, 2, 3, 4, 5. There are two more that are missing. What are the other two? 1, 2, 3, 4, 5. Okay, in optics, by the way, luminous intensity. Luminous intensity. Oh, and there is one more that I didn't put there. The unit of luminous intensity is the candela. There's one more here in thermodynamics that I didn't put it. And by the way, it should be before that. And what this other idea is the temperature, the idea of temperature. Okay, here you go. 7 total. Okay, someone. Makes sense. Okay, we didn't. You didn't look into that yet, but you have. Most of you have seen all of that. Some of you who didn't take E&M haven't seen the idea of electric charge yet. If you have taken thermodynamics, you have seen the idea of temperature and amount of a substance. Okay. What else? Let's go for the primary definitions. You know, that's nice about primary definitions, that you have to memorize only 2 of them. Okay. Here on basic quantities, we are familiar with those 3 basic quantities. Let's see, we're familiar with those 4 basic quantities since we are a little kids, right? So that's already should be part of ourselves, that we should have already a good idea of all those 4 quantities are all about. You know, it is like just like length, time, mass, and temperature is like just like breathing, right? Walking and breathing. You know what those things are. You don't even have to think about them. It's already part of, I would say, even already part of your DNA. The other 3 are a little more tricky, right? You need to go to college or to the school to learn about them. In general, it's not part of your DNA, but it is out there. Those 3 are important. The other 4 is just, you know, you already have an idea what it is since you were a little kid. What about the other 2? What about the primary definitions? Okay, there are 2 important primary definitions. Position. You know, in one-dimensional physics, we represent that by the x position. But if it's two-dimensional, then you have to represent it by, oh gosh, I hate that. You have to represent it by a vector. The vector that we usually use, vector, okay, is the R position vector, right? The unit of this guy is the meter. I want to put this one in parentheses, but not the other one. One-dimensional physics. You see that in kinematics. That's the starting point of everything. To find out about position, you have to use a Cartesian coordinate axis, something that we learn in math, a concept that we invented to locate things, right? And the other important primary definition, which has been around since antiquity as well, is the idea of force, okay? This is a very successful idea, a very successful concept. It's note that those two definitions, they are both vectors. That's the important difference between a basic quantity and a primary definition. Okay, here you go. And then that's how physics is set up. Those are the basic ideas. We have been very successful with those basic ideas, the basic quantities and the primary definitions. And then as time goes by, scientists discover the laws of physics, some of the laws of physics, okay? Those ideas have been around before any of the laws of physics. Length, time, mass, temperature. Amount of substance came later on, right? Position and force have been around for a long time. What took time to come up are the laws of physics. We know of two. I like to tell my students that we have two laws of motion and one law of gravitation and one law of universal gravitation. Why do I say that? Well, you might challenge me and tell me that there are three laws of motion. I'm going to tell you, actually, it's not three laws of motion, it's two laws of motion. The first, what people call the first law of motion, is in reality a special case of the second law of motion. Okay? Net force equal to zero, you know, you're moving with constant velocity or you're at rest. Okay, that's covered by the second law of motion. So here you go, we have three laws of motion here for mechanics. Then in thermodynamics, we have four laws. You know, the zeroth law, the first law, the second, and the third law of thermodynamics. And finally, E and M, electricity and magnetism. We have four laws. We have the Maxwell's equations. Okay, four laws. Okay. There are more. There are more. I will introduce you this semester. I will introduce to the laws of relativity, two, and the laws of quantum mechanics. Okay. You know, the greatest contribution that you can make to science is to discover a law of physics. if you can come up with a law that encompasses all those 3 laws of mechanics, you came up with a huge contribution to science. If you could somehow, come up with a statement or a formula that encompass all those 3 laws of mechanics, it's a huge contribution. Similarly, if you can somehow come up with a formula that encompass all those 4 laws of thermodynamics, is the same thing. It's a huge contribution of physics. The idea today is to figure out a law, a single law that will merge all those laws that you see right in here. The law of everything, the theory of everything. That's the challenge that we have today. Okay. So here you go. So this is an ever-evolving activity, enterprise. There's an ever-evolving enterprise. Every now and then, we discover something new, right? Even this basic quantities, I told you, that those, wait a minute, not vectorial, is scalar. Here you go, scalar. Vectorial is this one here. See the difference between those two? One is vectorial, the other is scalar. For the sake of this course, you are safe to think of those basic quantities as independent quantities of each other, even though it's not completely true because of relativity theory. I'm going to. Did you get? Do you understand that? Okay. And by the way, this law of Newton here, this law of Newton here, which has a unit of newtons, right? Oh, no, sorry, not a law. This definition, this primary definition of force, which has a unit of Newton, we can find out how Newton, the unit of Newton, is broken down into the main quantities just by referring to the second law of motion, right? F equal to ma. So if you're calling the unit of force as being the newtons, then this unit of Newton is going to be given by meters per second square. And where this unit comes from? It comes from the second law of physics right now, right in here. Newton is not an independent quantity, it's a dependent quantity, but its quantity force is a primary definition. Every other definition that we come up with comes from those two, in combination with the basic quantities. Okay, that's a very good piece of knowledge that you have to understand, that you have to have to better understand physics. Any questions about that? Okay. So absorb that a little bit. Remember, if you have, that's what you have to memorize for the rest of your lives. Okay. If you have to memorize anything for the rest of your life, that's what you have. The above information is something that you have to memorize for the rest of your life. Okay. You're not gonna memorize a big formula, no? You would memorize those 3 core concepts of physics. You go, building blocks, how physics is organized, or the building blocks of physics, or the core ideas, concepts of physics. So from all those ideas, then now we can come up with the secondary definition. Right? What would be one the next secondary definition, okay, what I tell my students is that displacement. Displacement is a secondary definition. Is what we call delta x. Final position minus initial position. Okay, go. Subscript, yeah. Go x naught. That's one secondary definition that comes from this primary definition that you see here. And then we have also what I call a tertiary definition. What's that? Average velocity, which is what? I'm going to put the one-dimensional case, right? Delta x over delta t. This tertiary definition uses a secondary definition plus a basic quantity. Okay? And then so on, right? Average velocity, instantaneous velocity, acceleration, and so on, and so on. Let's put it here. And so on. But what do we have to do today? Well, what we have to do today, we're going to talk about oscillations today. That's what we're going to start talking about oscillations. And then we have half an hour to talk about that. Then we take a little break for our lunch. Right, and I'll help you out with setting up everything for the lab, and then we can we can finish this meeting today, and we meet again tomorrow, right? So what's oscillations here? Let's talk about the topic of oscillation. That's chapter. Which chapter is that? Chapter. This one here? No, that's not this one. This one here? Chapter 15 of the book. Chapter 15 of the book. Why do we study oscillation, right? Why do we study oscillation? Okay. Have you ever thought about what if we can apply this type of knowledge somewhat? You know, think about that. What we can do with oscillation? Huh? Is there any practical applications to oscillation? Have you ever thought about that? Or are you just creating concepts out of nothing, just to fill your head with something that has no practical use whatsoever? Huh? Have you ever thought about that? Why is that? Oh. Anybody can tell me why do we study oscillation? I want to hear from you, in the chat window. That is best, so it doesn't overlap with anybody talking at the same time, right? Why do we study oscillations? Are there any practical applications? Okay. Are there any practical applications to oscillations? Modeling mechanics, designing bridges. Okay, good. Damping, modeling mechanics. Let's say yeah, everybody can see the answers, right? Damping, yeah. Designing bridges, yeah. Yeah, that would. But you know, I'm anything else. You know, when I think about oscillations, I think about yeah, dumping would be interesting. Yeah, you designing bridges, not just bridges, but buildings as well, right? Modeling mechanics. I guess Daniel means, you know, wants to when he mean about modeling mechanics. I guess Daniel were trying to say designing bridges, right? Or dumping. But what else? There's one more important application that I like to always mention to my students because it is related, closely related to one of the basic quantities of physics. Can you figure out which basic quantity of physics is closely related to oscillations? Optics. Okay. You can say that the electric and magnetic field oscillates, right? But think in terms of a mechanical type of application, not an optical type of application. Okay. No, waves. Oh yeah, waves. That's a good. Oh, here you go. We got it. Okay. Yeah, waves is a good one. Yeah, waves is a good one. And then Harun told us pendulum, right? The pendulum. What can you do with a pendulum? What can you do with a pendulum that's closely related to one of those basic quantities in physics? What can you do with a pendulum that's closely related to this, to one of those basic quantities? Let's zoom in. Oh, here you go. Here you go. Yeah, here you go. The Shah, right? Shah, he came out with it. So that's the first thing that I think in terms of oscillation. Okay, every time I think in terms of oscillation, I'm thinking, you know, every time I think of oscillation, I think in terms of a timepiece, a device to measure time, to measure the passage of time. Okay, which by the way is related to it, which by the way is a basic quantity in physics. But the other ones that you folks mentioned, you know, it's pretty related too. Okay, wave, yeah. In order for you to understand what wave is, you have to understand the oscillations first. Okay. If you're going to build a building, yeah, you have to make sure that the building will undergo some oscillations to preserve its structure. Nobody ever designed a rigid building, especially in the regions of earthquakes. Okay, a building must be able to flex, not just buildings, but bridges must be able to oscillate, flex whenever subjected to some sort of disturbance, otherwise the building doesn't fall off. Okay, but there is a very, but going back here to a timepiece. Okay, we take those things for granted, right? Today we take those watches for granted, but it wasn't always like that. It wasn't always like that. Very good, reliable timepieces start to be developed in the 1500s. Okay. Before then, we have some timepieces that are not very good, you know, and we couldn't control that very well. Even before the invention of any timepiece, people would use the stars and the sun as a way of keeping time. Okay, but you know, mechanical. What do you have to say? Mechanical timepieces use oscillations to keep time. That's why it's so important to study oscillations. Okay, historically speaking, it's a fascinating story. Okay, how we came up with very accurate mechanical timepieces. You can go into Wikipedia, and you're going to learn that a very good starting point for very good timepieces was back at the time of Galileo Galilei, right? He was at the church attending service, right? Something that I learned since I remember learning when I was a kid, He was at the church and he noticed the chandelier of the church, the oscillations. He noticed the oscillations of the chandelier of the church, moving back and forth, moving back and forth. Think about that. Before Galileo Galilei, everybody, a bunch of people had noticed that. When they were at the church, they would see the chandelier moving back and forth because the wind was blowing there inside the church from the outside. But they never bother about making a connection between that oscillatory motion and the development of a accurate and precise timepiece. It took thousands of years for someone to come up with this idea, and it took someone called Galileo Galilei. When he looked at that chandelier oscillating back and forth, he came up with this idea. Can I use this device to keep time? Can I use this type of motion to keep time? Galileo himself was concerned about measuring time because he was performing experiments. He needed to have a very accurate way to measure time. And like I said, anybody else could have this idea, but it was Galileo who came up with the initial idea of using a pendulum or the back and forth motion of oscillating device to come up with a timepiece. Okay, it's a fascinating story. Okay, and then what happens? If you go into Wikipedia, you're going to learn, right? Galileo had this idea, kept it in the back of his mind. He went doing some other things. He went discovering the moons of Jupiter, the spots of the sunspots, and many other things. Eventually, he ended up being persecuted by the church of the time. He was embarrassing the authorities, and they gave him a choice. You can recant your ideas about sunspots. You can recant your ideas about the moons of Jupiter. You can recant your ideas about the mountains in the moon and the phases of Venus. You can recant your ideas about the sun being the center of the universe, or you can, die. We're gonna go to kill you. Basically, that's the choice they made to Galileo. And Galileo didn't want to die, right? And he recanted his ideas. And he didn't teach anymore. But that was not enough for the church. The church went a step further. Not only made him recant his ideas, but they also put him under house arrest. So Galileo was incarcerated there in his estate. He spent the rest of his life in his estate, couldn't live there. But interestingly enough, it was a time, even though he was under house arrest, that was the time when he was the most productive in his life. There was no distraction for him other than his own revolutionary ideas. And it was during that time that he started to build the first timekeeping device using a pendulum. At that time, Galileo was already blind, so he couldn't perform the building of his pendulum-based device. So by being blind, right? He became blind because he was observing the sun through his telescope. So he came up with his son. That's a nice story that's in the Wikipedia. you know, why don't you help me with this project, right? I want to build a timekeeping device based on pendulum. Oh yeah, that's pretty good. Oh, I can help you, Daddy. Yeah, I can help you, Dad. But then it was the end of the life of Galileo. Galileo died. Before dying, he started working on that timekeeping device based on pendulum. And he died, and his son continued his work. But then what happens? His son dies soon after as well. It looks like 2 more years he lived, and he couldn't finish the work of his father. Okay. So Galileo, the idea is that Galileo tried to build the first timekeeping device based on a pendulum. So Galileo and his son couldn't finish their work, but someone else came along. Let me share the screen here with that Wikipedia. You go time, let's see, clocks, right? Clocks, Wikipedia. I'm gonna refer that to you if you want to find out more. It's a fascinating story, okay? It tells us a lot about how those things, let's see, history. Let me see, sundials, that's one way of keep time. Fully mechanical devices, water clocks, pendulum, finally. Spring driven. Let's see here. Here you go. Okay, the next development in accuracy occurred in 1656 with the invention of the pendulum clock. Galileo had the idea to use a swinging ball to regulate the motion of a time-telling device earlier in the 17th century. And then he died, right? They don't explain that to you, but he had the blueprints of his device. After dying, someone else picked up on his idea. It was Christian Huygens. He was a Dutch physicist, mathematician, astronomer, and inventor as well. Very famous guy. You know, so he is the one that's credited with the invention of a timekeeping device based on pendulum, okay? So he determined a mathematical formula that we are going to derive, by the way, and they didn't elaborate on that. That's a shame. But the story of Christian Huygens is amazing, okay? So what Christian Huygens did, he took the idea of the pendulum and developed a device that was used in conjunction with existing mechanical clocks that were already in existence. They tell that somewhere else, not here. Okay. So basically, he adapted existing clocks using pendulum. Okay, so that's the idea, and it was a huge development. He increased the accuracy of existing clocks by 60 times, almost 100 times. Okay, so if you are an inventor, you're not going to invent something that's going to increase an accuracy or going to get better or it's going to be cheaper by twice, you know, half cheaper. You're not going to do that. Nobody's going to pay attention to you, okay? If you really want to have your invention, you know, people to pay attention to your invention, you have to come up with something that's at least 10 times better, 10 times cheaper, 10 times more accurate, 10 times faster. And that's what Christian Huygens did. He came up with a timekeeping device that was 60 times more accurate than existing clocks. And on the top of that, he didn't stop there. He didn't invent a new clock. He didn't invent a new timekeeping device. He invented a device that could be interfaced with existing clocks. So instead of throwing away existing clocks, you would get the existing clock that was in there. Oh, I'm going to make a slight modification to this clock. I'm going to add my pendulum bob there to this device, and I'm going to make this pendulum far more accurate than what pendulum exists out there. Okay, than the existing pendulum out there. That's what Christian Huygens did. Okay, and that's why I say it's a fantastic idea, it's a fantastic story. Okay. But let's see how we can, what's the theory behind all of that, right? Okay, so after the death, okay, of Galileo and his son, who were building a timekeeping device made of a pendulum, his son, they couldn't build Christian Huygens, right? Huygens followed up. Let's see here. Huygens followed up on their work and built the first pendulum-based timekeeping device, which was 60 times more accurate than existing mechanical clocks. On the top of that, he figured out how to use existing clocks with his own device. Okay? So that's what we have here, and but let's go to the real physics of what you're talking about. Okay, so how do we model this type of device? Okay, how do we model? And that's what the whole idea of this course is. We start with the simplest of them, the simplest pendulum out there, the simple pendulum. Okay, the simple pendulum. And let me go illustrate. Let me show you an illustration of a simple pendulum. Notes. Let's see. Go. Oscillations. Let's see. I don't want to talk about springs yet, but I'm going to talk about, let's see, I have, that's not a simple pendulum. But here you go. I don't have an illustration of a simple pendulum, unfortunately. Okay, so I have to draw it from scratch. That's strange. Okay, so a simple pendulum, what's that? A simple pendulum is a very simple device that consists of a string attached to a bob. Okay, here you go. Here you go. Here's the ceiling of your place in there. You go ahead, get a string. Okay. A string and attach to the end of this string a bob. Right in here. The string in this case, because this is a simple pendulum, has a negligible mass compared to the bob. Okay? That's what a simple pendulum is all about. Can you picture that? Just get a simple string, attach a mass to the end. Here you go. We have this length, this later on, we are going to talk about another type of oscillation, another type of device that undergoes oscillation. let's see here. Right here. The distance, it should be from the center of mass of the bob. Let's say this bob has a mass m. I can also state that the string also has a mass, but the mass of the string is negligible. I'm going to put here, here you go. Mass m, okay? And then, for completeness sake, I'm going to tell you that this string also has a mass. But, and, you know, any string will have a mass, but with an important condition. The mass of the string is much less than the mass of the bob. It's negligible. And by much less, you can picture it, what much less means. A very good rule of thumb for much less. A very good rule of thumb for much less is that it's 10 times less than the other. That's a very good rule of thumb for something that's much less than the other. Okay? If you have something like that, you can neglect the effect of the mass of this string. 1124, we're gonna we have 6 more minutes to go. And what we do in physics, we study this type of motion, okay? We study this type of motion. And how do you do that? Here you go. Let me put it aside. I'm going to put the vertical direction here as a reference. That's the y-axis. Okay, here you go. And if you want to know about the motion of this device, you have to come up with the forces, right? Just like we did before for any problem. And that's what we do here. Let's see here. What are the forces acting in this device? 11:25, 5 more minutes to go. Here you go. What now? Tell me, write that down. What are the forces that are being applied to this device? I'm going to the bob. What are the forces that are being applied to the bob? Here you go. Force of gravity, yeah, which is the weight, right? I'm going to even to come up. Which other? Oh, okay, good. Any more forces? I saw here gravity, the force of gravity, which is the weight, right? And don't forget, I'm going to the starting force. No, the starting force is just a consequence of the gravity. Yeah, you can say there is air resistance, but let's assume the air resistance is negligible. Okay, let's assume that air resistance is negligible. Restoring force, too, because restoring force is not a main force. Restoring force is related to the net force that we have there that being applied to the device. Okay, so if we're going to solve this problem, here you go. All you have to do is to worry about 2 forces. The force of gravity, or the weight, that's applied to the exactly at the center of mass of the device. Here you go. Format shape. Here you go. Yeah. Oh, applied force. Here you go. That's one force that's applied. I'm going to make it thicker to look nicer, right? I label it mg. Strictly speaking, you know, you could have identified a force applied to the string, okay? Right? Normal force? No, there is no normal force because there is no surface here in contact with the mass, okay? Resistance force, yeah. Resistance force is, so yeah, someone said tension, that's right, someone said tension, and the second force is the tension, right in here. I'm gonna put that tension right in here. Okay, so that's how we set up our problem. And let's not forget I was doing here, what I was doing here? I was no fill, yeah, no fill. I was doing this square here just to remind you that I am isolating, I'm looking just at the forces applied to the bob alone. Okay, here you go. Remember we do that in physics? We isolate the body and worry about only the forces that apply to that single body. The length of the string is L. Okay, you go, length of the string. There's no other force. That may be, yeah, there may be air resistance, but I'm neglecting air resistance. So let's write it down. There are three forces. Okay, three forces applied. Only three forces. There are only three forces applied to the bob of a simple pendulum. Okay, the first one that you said, the weight of the bob, the tension, the string applied. Okay, so let's see. There's not three. There are four, right? Let's see, four. We can even say five if you want. You know, five forces applied to the bob. No, to the bob. Okay, force five. Only three forces. No, applied to the bob. Okay, we're not talking about the. It's three forces. So the bob is only three. Weight of the bob, the tension of the string. The tension of the string applies to the bob, and air resistance. However, air resistance is negligible because of the low speed of the bob. Okay, yeah. So this list of three forces become only two. Okay, it's 11:30 right now, and I want to, stop my lecture here, and I will continue this problem tomorrow. And what we're going to do, we're going to go for a break, right? Going to go for a break till 12 noon when we start our first meeting, lab meeting. In this lab meeting, I'm going to do some preliminaries. We are going to do some preliminaries. Okay, what we're going to do? One, you're going to choose your group members. You're going to choose your group members. Since we have a large class, no more than 4 students per group, okay? We're going to do preliminaries. Just a preliminary. I'm not going to do any experiments whatsoever. Two, what else? I'm going to show you how to plot graphs. You should know that already, right? Because you're taking this course, at least this is at least your second course in physics, right? How to plot graphs. I'm going to tell you how I do business in my lab. Well, in my lab, I'm talking about in terms of sig figs. Okay. especially in terms of statistics, because I do slightly different from other professors out there. And what else? What else? Oh yeah, we're gonna set up your groups folder so you can download your data and upload your reports. Okay, so that's what we're going to do at 12 noon. Any questions? Any questions?
Professor, for us that are waiting to add, are we gonna choose group members too, or I guess we would wait till tomorrow, huh?
Let's see how we're gonna do. Yeah, you have a very good question. Let me see how we're going. Choose a group for now. Yeah, because yeah, go ahead, choose a group yourself. We have 3 students there in the wait, 2 students in the waiting list, 1 more that's trying to add, right? Okay, why don't you 3 make a group yourself for now, and by tomorrow, exchange your information with each other, and by tomorrow I'll decide what we're going to do. I need to see what's the status of those other students who didn't show up, and let's do this way. Okay.
Okay, sounds good.
Okay, so exchange your information among yourselves. That's gonna be what Olivia, right? Sarina and Alexis, and you start with your group at this moment, and then by tomorrow I may have a decision what we're going to do with you. Okay. Okay, so let's it's 11:35 right now. Let's have our break until 12:05. Break till 12:05. Okay, half an hour. So you have enough time to eat something, grab something to eat and drink. I'll do the same. I'll see you in half an hour.
Professor, I'm gonna leave and then just join again rather than staying on, if that's okay.
Okay. Yeah. That's okay. 32. Blue. Okay. Okay, I'm back here. And let's see. The content. Okay, so two. So what I'm going to do, I'm going to take attendance again, and I'm going to keep attendance for the lecture separate of the attendance from the lab, okay? So make sure you are here for both of them. Okay, so I will take, let me share the screen here. I'll take attendance, lab attendance separately. In the lecture. Make sure you are present, both of them separately. So let's see here. Toby, are you here?
Yes, Professor, I'm here.
Okay, good. Harun, Asif, are you there?
Yeah, I'm here.
Musa?
Yeah, I'm here.
Right. Jumai Bandali?
Yes, here.
Okay. So let's, what the heck is that? Oh, yeah. Zachary Blue?
I'm here.
Okay, Elena, right? Both hard.
Here.
Luis Ezian.
I'm here.
Okay. Okay, thank you. Brian Spino. I don't see Brian here. No. Yeah, Brian didn't show up. Okay, Robert Faust. Okay, thank you. Pedro Flores.
Yeah, I'm here.
Lawrence Flores. Lawrence. I don't see Lawrence here. Daniel Freire.
Here.
Amalia Gale.
Here.
Tiffany Wang.
Here.
Olivia Kroger.
Here.
Okay. Daniel Liang. Daniel was here before, wasn't that? No. Yeah, he's in the list, but he's not answering.
Professor, he said he's here in the chat.
In the chat? Okay, thank you. Yeah. Here you go. Let me put it closer here to my nose. Otherwise, I might miss you, right? Daniel, okay. Anthony Lopez, are you there?
Here. I'm here.
Okay, great. Thank you. Chuk Lu.
I'm here.
Dave Dimas.
Here.
Ryan McNeil.
Here.
Gabriela Montes. Okay, I don't see Gabriela. Daisy Magbo.
Yeah.
Okay, Daniel and Daisy, right? Daniel as well?
Yeah.
Okay, good. Claire Ottinger.
Here.
Angela Padua. Angela, I don't see Angela in the list. Maria Raju. I don't, is Maria there? No, I don't see Maria in the list either. Jennifer Ramirez. Okay, thank you. Noah Raymond.
I'm here.
Okay, George Risk. Safi.
Here.
Natalie Santiago.
Here.
Nathan Silva. Nathan, okay, I don't see Nathan in the list either. Darnice Simon. I see Darnice. I don't see there. Okay. Kadi Sobi. No. Okay. Aidan Tadeo. Was here before, right? No longer. Nope. Sandra Valencia. The Valencia. Nope. Kenny Villagomez.
Yeah, I'm here, Professor.
Okay, thank you.
Yeah.
George Risk. Okay, George. Robert Wall. Oh, George Risk. Okay, everyone. Robert Wall here. Nope. Nolan Williams. Yeah, okay, thank you. George Risk, let's see. Yeah, George Risk is here. Mengshu Zhang.
Here.
Okay. Ki So. I don't see. Okay, next. Olivia Song, are you there?
Yes, I'm here.
Okay. Sarina Lobana.
I'm here.
And Alexis Negret.
Here.
Okay, so let me see. 32, 30. Okay, good. So we have the right number here. And the first step is to choose your group members, okay? No more than 40 students per group. So group number. I'll give you some time to do that. Hopefully you already know some of you, right? Choose your group members. No more than 4 students per group. Okay, so let's see.
Professor, could
Yeah?
you make it possible for us to private message people on Zoom? So ask
I
people-
don't think it's possible to do that through Zoom. Let me see if I can. I once tried to do that before, but I couldn't. Ideally, right? It should be, let me see here. Host and co-host, see, it has only participant can chat with no one, host and co-host, and everyone. You know, it doesn't have any other choice other than those three. You know, I'm sorry, it doesn't look like I can do that.
Is it possible for you to create the groups yourself, since I'm assuming everybody doesn't know each other in this class?
Okay. Yeah, we can do that. We can do that. So let me see. Let's start with Toby, right? I'm going to do the following. I'm going to call you one by one, right? And I'm going to ask you whether you know anybody in the class that you want to join in the group, right? Toby, do you have a group already?
Yeah. Can I join him?
Who's that?
Can I join Toby?
Who is that? What's her name?
Pedro.
Pedro. Okay, Pedro Flores, right?
Yes.
Okay, Pedro Flores. Okay, group 1. Okay,
Professor,
you gotta.
could you add?
Yeah.
Could you add me? I'm Kenny.
Kenny. Okay. Yeah. Okay. So you're Kenny Villagomez, right?
Yeah.
Yeah, you were in the same group last semester, right?
Yeah.
Anybody else wanna join Toby's group? Anybody else?
I'll join.
Who's
Hello,
that?
Nolan.
Yeah, Nolan. Okay, Nolan Williams. Let's go here. Okay, 4 students. Group 1. Good. So Harun.
It's me and my brother right now.
Okay, so do you know anybody else that might want to join your group, Harun?
No.
Okay.
Who is that?
David.
David what?
David Marble.
Send a text message, please. Dave, let me see. I didn't
It's
understand.
number
your last-
23.
23? Ah, okay.
Or 24.
Dave. Ah, okay, 24. Okay, good. So Daniel, do you wanna join them too?
Yeah.
Okay, 2 brothers, 4, a group with, 4 brothers, right? Here you go. Harun and Musa and Daniel and Dave, right? Here you go. Nice. Now, Jumai, do you have a group? Let's see here. Let's see, looks like walked away. Jumai walked away. Might have lost internet connection. Let's see. Yeah. Are you there, Jumai? No? Okay, I'm going to skip it for now. I'm going to put a star here. Zachary, do you have a group?
I don't. I have no preference. You can throw me wherever.
Okay, so, let's see how I'm going to do that. I'll put it like number 3, okay? Group number 3 for now. Elena, do you have a group?
No, I don't have any preference either.
Okay, would like to join with Zachary?
Sure.
Okay, so let's do that. Luis, do you have any group members there that you'd
No,
like
you
to?
could put me in 3.
3 as well? Okay, good.
Can I
Brian?
get into group 3?
Yeah, Brian, okay, good.
Or
So,
no, David.
Dave, group, Dave, which Dave do what?
Maze, M-A-E-Z.
M-A-Z. Okay, this one, group 3. So we have 40 students in group 3 now, right? Jumai did the, no, not yet. Okay, let's see. Brian Spino, do you have a group? No, Brian's not here. Let's put 0 here for now. I'm gonna put Jumai 0 for now. Robert Faust, do you have a group, Robert? No, okay. Okay, let me put you at group number 4 for now. Let's see, 2, 1, 2, 3, 4. Lawrence Flores, do you have a group, Lawrence? Lawrence, okay, Lawrence must having connection problems. Daniel Frady, do you have any group?
I do not.
Okay, so let me see. Okay. Okay, would like to join with Robert, group number 4?
That works.
That works? Okay. So go ahead, Robert, start with, exchange information with Daniel and Amalia Gail.
I think Shah Safi. I don't know if that's how to say his name correctly.
Yeah, I want to be in one group.
Okay.
Yeah.
Okay, so I want to put you in group 5, right?
Okay.
Shans, what's the last name?
Safi.
Safi?
Shah
Okay,
Safi.
Shah, okay. Group number 5. Anybody else want to join this group? Okay, who can? Okay, let's go to the next, and then Tiffany. Do you have a group, Tiffany?
I don't have a group, and I'm free to join any group.
Yeah, which one? You have a choice between 4 and 5.
I guess I'll join 5.
5, okay. Good. Olivia Kroger?
I don't have a group and I don't have a preference.
You don't have any preference? Okay. So you'd like to join with Robert and Daniel?
Yeah, sure.
Okay, good. So I'll go ahead and start exchanging information among yourselves here. Let's see, Daniel Liang. Are you there? George Rick? Okay, so let me see. Which group is George Rick? Does he have a group already?
Not in
he
a
doesn't
group.
have, no,
Yeah.
he doesn't have a group yet. Okay, so let me see. You're going to be group number 6, right? And George is going to be group number 6 as well. Anthony Lopez.
You can put me in group 5, please.
5, okay, so don't forget only 4 students per group, right? Let's make sure we have 4. Now we have 4. So this group is closed. Chuk Lu.
I don't have any preference.
Okay, would like to join group 4. 4,
sure.
Yeah, group 4 has, let me see, Robert, Daniel, and Olivia. Okay, so group 4, here you go. Let me see how things are going here. I didn't get to the students that are. Okay. That's sort group number. Okay, so that's the situation so far. 1, 2, 3, 4. 1, 2, 3, 4. Right. 1, 2, 3, 4. 1, 2. Okay, group 4 is closed as well. 1, 2, 3. Okay, let's take a look at next in line here. Ryan, do you have a group?
No.
Okay, you want to join group number 6?
Sure.
Daniel Lang, George Risk, 6. Okay. Gabriela Montes, not here, right? Gabriela Montes. Claire Huttinger.
I don't have a group yet.
Okay.
And no preference.
Okay, so let me see. We have one more slot in group number 6. Want to join them?
Sure.
Okay. 5. Let's see. 4. Let's see here. Next. Oh, yeah, because I still have those 3. Okay. Next. Angela Padua. No, Angela Padua is not here. Maria Raju. No. Maria Raju. Jennifer Ramirez. Jennifer, she answered right. Jennifer, are you there? Okay, good. Do we have do have any groups that you want to join? A group preference. So you have how many students here? 4. Yeah. Okay, you have 4. Okay, so let's put you in group number 7 for now. You're for yourself. Noah Raymond.
Hi, Mingshu and I wanted to be in a group together, so we could both be in group 7, I guess.
Group 7. Okay. Okay, with Jennifer.
Yeah, and then Mingshu wanted to be in our group too.
Okay, so how do you spell Mingshu?
From the bottom.
Yeah.
Mingshu. Okay, this one. Okay, good. 7. Mingshu Singh. Okay. Okay, good. So start exchange. What about Natalie? Natalie, do you have any group preference?
You can just add me to group 7.
Okay, good. Group 7. Okay, so now what about the waiting list students? Were you able to exchange information among yourselves? Olivia, Sarina, and Alex's. Did you making a group? Did you make a group yourself?
No, I don't have groups.
You don't have groups? Okay, so I mentioned during the break, right, that you three could make a group among yourselves. Okay, is that okay with you?
Sounds good.
Okay, so go ahead, exchange information among yourselves. 32.
Professor, can I see group 5, please?
Let's see, group 5. Let me organize here first. Dave first. Okay, here you go. Group 1, right? Here you go. Memorize. Jumai, is she here? Disappears? Yeah. Okay, group 2. That's group 2. So memorize who you are with, right? And start exchanging information among yourselves. Group 3. Okay. Group 4. Okay, check your Canvas inbox. Okay. Oh, group 5 was asking for group 5. That's Anthony, or Anthony, you're asking for that, right? Okay. Group 5, Amalia, Tiffany, Anthony, Shah. And then group 6. Daniel, George, Ryan, and Claire. Group 7. Jennifer, Noah, Natalie, and Mengshu. And we go. Group 8. Okay. So we are done with choosing your group members. Here you go. You're going to choose your group member. You're done with that. Let's do this one later on, right? And let's set up the group folder right now. I'm going to give you a link. Okay, I'm going to give you, I'm going to do the following. I'm going to create a folder in my Google Drive with for your group. For your group, don't share, and I will provide you with a link for this folder. Don't share this link with anyone outside your group. Okay? It's okay to have your group members. It's okay to have your group members having this link, but do not share that with anybody else outside your group. So let's do it. Now here you go. Google Drive. Go to Drive. 2022. Let's see. I am going to go here. The new folder. Summer. Okay. Oops. What did I do? Yeah, wrong one. Here you go. I'm going to create a group folder. Huh? Not what I want. New folder. Here you go. Group folder. And then I'm going to start here. New folder. Group number 1. Group number 2. Group number 3. Group number 4. 5. 6. 7. And 8. So he go, I am going to create a link. Let's see, he go, only people here. Let me see how I'm gonna do that. Anyone with the link. But then how do I view it? No, editor, okay. So I'm gonna copy this link. Let's see, who is the first in line here for group number 1? Group number, Toby, okay? I'm gonna send you the link in a private, through the private chat here, and then you share with the rest of your group members, okay, Toby? Are you there, Toby? Not answering.
You
Yeah.
can send it to me if you want.
Yeah, I'm sending it to you right now. Okay,
Okay.
so you use this link to open that folder, make sure everything, and then share that with Pedro, Kenny, and Nolan. Okay, you get the idea. Now let's go to group number 2. Dawn, you can edit it. Let's see, share, restrict, anyone is the link, edit. Now copy the link. Done. So let's go here to Musa. Okay, Musa, share your link, share this link with your group members, please. Okay, and next in line, group 3, Zachary. Do you understand what we're doing here? My students who took the course before, they already know what I'm doing because that's how I used to do things, right? Now, let's go for someone else here. Arun. Group number 3, Zachary. Are you there?
I'm here.
Okay, so let me get your group link. Edit. Copy link. Don Zachary. Now let's see, Zach. You know what you have to do, right, Zach?
Yes, I understand.
Okay, good. So that's the link for your group folder. Share that with the other students in your group. Share with next. Editor. Okay, copy the link. Group number 4. Robert, I'm gonna send the link to you, okay, Robert? Daniel Freire. So share that to your group members. There, Robert. Here you go. Robert for Daniel Freire. I want to send to Daniel Freire to help you out, folks. Yeah, okay, Daniel. Share that with your group members. Both you and Robert, they have the link for the group folder. Share with the other ones, please. Amalia, you're next here. Amalia, let's see here. Amalia Gale. This one is group number 5. Okay, Amalia, share that with your group members, please. Tiffany, Shah, and Anthony. Let's see, group number 6 now. Just missing Robert. Robert, which Robert? Oh no, let me send that to group number 6 first, and I'll help you out. Jennifer Ramirez. Oops, Jennifer, that's the link for your group folder. So do we need help, Daniel? No worries. I thought I went directly to him. Okay. Okay. Good. So now the last but not least, Olivia. Hey, wait a minute. What did I do here? Oh, it looks like I sent to the wrong person. Okay, Jennifer, delete that link, please. It's not supposed to be to you, for you, okay? Let's see here. Yeah, I made a mistake here. Okay, so delete that link, please. I should be sending to Daniel. Daniel, did I send you? Let's see. I didn't send. Okay, I'm gonna send to Daniel. Daniel Liang. Okay, okay. So let's see if I have it right. Okay, copy the link. Okay, good. That's for you. And now, Jennifer, I'm going to send you your real group link. Share. Editor. Copy the link. Dawn. Jennifer. Okay, now it's your real group link. Okay, keep those links in a safe place, please. One more, right? One more. Olivia. Is that Olivia Song? Oh, there's Olivia Kruger and Olivia Song. Huh? Okay, let's see here. Can you send the link to different person? Yeah, I can do that. Let me see here. So Sarina, can I send that to you, Sarina?
Yeah, sure.
And then you share with everybody else in your group, please. Group 8. Okay. Should be Alexis and Olivia. Let's make sure you have everything right? We're gonna go through this exercise. What's going on here?
Professor.
Yeah.
Could you send me the link? I'm in group 1 and my name's Kenny.
Okay, hang in
just
there.
Just in case Toby doesn't send it.
Okay, so let me see here what I'm gonna do. Okay, you're group number 1, right? Kenny Villa Gomez.
Yeah.
Okay, Toby got the link, right, Toby?
I'm not sure.
You're not sure?
Yeah.
Okay. Copy. Kenny Villa Gomez?
Yeah.
Okay. I don't see it in your list. Why is that?
Or maybe you can send it to Pedro Flores. He's also in the group.
Pedro Flores. Okay.
Yeah, he's also in the group.
Okay, Pedro Flores. That's group number 1.
Right.
Okay, check it, Pedro.
Thank you, Professor.
Okay. Okay, so let's go through some exercises to make sure everything is correct. You know, as you can see, sometimes I email the link to the wrong person, but we can make sure everything is working correctly. Here you go. Cool. What you're gonna do? Here you go. 1. You know, using the link I sent you, using the group folder link, your group folder link. Folder link, access its folder. Okay, so go ahead. Everybody, I want everybody to do that. Make sure that if you're group 1, you're going to click in that link and you're going to get into this place right in here. Right now, there's nothing in the folder. And you should read your group number here. If you are with group 1 and you read group 1 here, you have the right link. If you are in group 2 and instead you see group 1 here at the top, you have the wrong link. And let me know. If you have the wrong link, let me know. Okay? Okay. Let's go one by one. I'll give you some time to do that. Go ahead, access your group folder. I'll give you like 3 minutes to do that.
We're just uploading any random file, right?
Don't put the files yet. Don't put the files yet. I want to do it in a more controlled fashion, okay?
Oh, okay.
Just go ahead, open the folder, make sure your group folder is the right one. You know, here's the folder for group 1, right? Here's the folder for group 2 and so on. Okay, I have someone already did that something. Let's see, 3, 4, 5, 6. And again, I want you to make sure the folder corresponds to your group number. Someone else is coming. Okay, I'm going to access this folder. Make sure the group number, the top, at the top, corresponds to your own group, right? Using the link access, click the link, click on your group folder link. Oh gosh. On your group folder link. Make sure the group number at the top of the page. Your own group. Okay. Okay, so having said that, I am assuming that you all got your correct link. If you didn't, let me know. All right, let me get someone at random here. Make sure that, let's see, Chuck Lou, right? You get your correct link there?
Yeah.
Yeah, okay. You're supposed to, right? Your group number 4. You're supposed to see group number 4 here once you click on the once you go inside your folder. Okay. Good. So I am confident. Do you mind sending me the group 7? Let's see, link again. Let's see what's going on. Let me get that for you. What, you couldn't open the link, Mengshu? What was the problem?
Oh wait, never mind. It's okay. I have it now. It's good.
It's working? Okay, good.
Yeah, thank you.
Thanks.
I don't think I got the link.
Who is that?
I don't think I did not get a link.
I know. Who is that? What's your name?
Oh, Claire, sorry.
Claire. Okay. Which group are you, Claire?
4-6.
4? Your group is 4?
6.
6. Okay. Group 6. Let me double check here first. Claire. Yep. Group number 6. Now let's go here. Okay. Yeah. Claire, you're listed here. You want me to send the link again?
Let me check again. Sorry.
And again, make sure that you keep this link in a safe place. You're going to use it for the rest of the semester, right? Here you go.
Okay, I got it. Thank you.
Okay, good.
I don't think I got my link.
Okay, who's that?
Olivia Kroger for group 4.
Okay, Olivia Kroger. Let me get the link here. Use the link, copy the link, group 4. Olivia Kroger. Okay, group 4. I got the link.
Olivia, it's in the general channel of our Discord that we made for group 4.
Okay,
Oh, sorry, I was looking in the
Oh, no,
wrong.
you're good. You're good.
Okay, Olivia, I send the link.
Okay, thank you.
Okay. Anybody else?
Yeah,
Anybody
I
else?
didn't get mine.
Who's that?
Toby.
Toby, you didn't get yours? Okay.
No.
Toby. Your group number 1, right, Toby?
Number 1, yeah.
Copy link. $12.50. Okay. Anybody else? Okay, so let's go ahead and do another exercise here. Make sure everything.
I'm not in a group.
Who is that? Oh, yeah. Okay.
I'm
you
not
just
in a
joined.
group.
Yeah, you just.
I was
joined,
having connection issues earlier.
Okay. So let me see here. Let me sign on. Let's see. Okay, here you go. Okay, attendance. Here you go. Let's see how I'm gonna do with you, Darnis, right? I have only room here on group number 8. Okay, Darnis, I'm gonna put you on group number 8. Share your information with those students. Contact information with those students. Olivia, Sarina, you're gonna go be in their group, and I will. Here you go. Anybody else? Okay, so I presume everybody having access to the group folder. What I want you to do next, I want you to upload a file from your hard drive. to the group folder. Okay, any file, any file. Hard drive to a group folder. Don't create anything new, just upload there. You know, find a file. What are we doing here? We're just checking, making sure that you can upload files. That's all. Okay? You just click, drag, and drop at your folder. Here you go. For group number 1, you're here inside, right? You're gonna click a document in your computer, drag and drop. Okay? Drag and drop there. I want to make sure everybody does that. Put your name in that file, preferably put your name in the file. So, well, there's no need to put your name. It's okay. So go ahead, start doing that. I want to start seeing files here inside those group folders. Group 1, 2, 3, 4, 5, 6, 7. While you do that, we're almost there at a break, right? Yeah, let's start a break a little bit earlier. You know, 12:55 right now. Let's go for a break until 12:20. In this meantime, you go ahead, click, drag, and drop a file there to the group folder. Everyone that has a link, please do that. Okay, upload a file from your hard drive to the group folder. You know, click, drag, and drop the file to your group folder. Okay, I want you to do that, and you know, there's a break now. Break, do a little bit longer break, so you can use part of this time to click, drag, and drop the file. Okay, so see you at 1:15. Okay. Okay, I'm back here. Okay. So let's see how you did here, right? I want you to upload a file, any file from your hard drive to the group folder. And let's see how it's going on here, group one. Huh? Ken, Toby, and Pedro Flores did. Who was missing from group one that didn't upload the file? Let's see. Nolan, I need you to upload a file there to your group folder.
I just did.
Okay, good. Good. Let's see everybody else. Group two. 1, 2, 3, 4. Okay, so I'm going to delete that. Okay, Musa, remove it. Maroon, Dave, and okay, so you know how to upload the files. Group number 3. Let's see, Zachary, Crystal, Elena, and Dave. Okay, good. I see group 4. 1, 2, 3, 4, 5. Okay, Chuck uploaded 2 files there. Okay, group 5. Little Prince. Okay. Shah, Anthony, and Tiffany. Okay.
Hi, Professor. That's my Google name.
Google name. Okay.
What?
Yeah. Okay, group 6. Let's see, group 6 here. Okay, only 2 students on group 6 uploaded. Now we have 3, so there is 1 more student that need to upload that. Daniel, Ryan, and Claire. That's group number 6. Daniel, what about George? Were you able to upload George? I need you to upload it. Is George there? Yeah, I don't see George in the list anymore. Looks like he got out, right? I'll keep track of along the class to make sure you're participating. Okay, it's important that you be here in real time. He's having internet connection problems. Okay, so please ask him to make sure he has a reliable internet connection. I'll leave 1 there for now, attendance for now. Group 7, let's see, group 7. 1, 2, 3, 4, main should, okay. Good, you're all good on that, huh? You know what you're doing. 1, 2, 3, 4, good. No secrets, right? And has a member. Group 6, what about group 6? Zach Blue. I don't know what I mean by a member. Okay, good. So okay, next thing, another exercise here. Okay, now see, go ahead and remove the file you uploaded remove from your folder, your group folder. Remove from your group folder the file you uploaded. Okay, all you have to do, that's straightforward, right? All you have to do is click on your file, right-click on your file, and remove. Right? Go ahead, do that. Make sure you know how to do. You are capable of doing that. Okay, I want to make sure whatever file you're uploading there, you go ahead, just remove it. And we are ready to go to the next step here. Okay. Okay, thank you, George. If you make sure you have at least a backup for the internet, like if you're at home and suddenly you don't have a internet connection, make sure that you at least have your cell phone can act as a hotspot, right? So it would be a backup for your home internet. Use the internet from your phone as use the hotspot option of your phone. It's important that you have a reliable internet connection for this course. Let's see if everybody deletes that. Group 1. Yeah, clean. Group 2. Okay, I need you group 2 to delete your files. Okay, group 2. Group 3. Yeah, group 3, Zachary and Dave, please remove your file there.
I just removed it.
Okay, good, thank you. Group 4, Daniel and Robert Faust, please remove your files there. Group 5, Anthony Lopez, please remove your file. Group 6. Okay, group 6 is clean here, great. Group 7, good. And group 8, okay, group 8. Just Olivia Song, I need you to delete your file, remove your file from there, Olivia, please. Group 1, let me go through again. Group 2, okay, good, good. Group 3, okay, now it's the turn of Dave. Dave the mess. Okay, good, Dave did that, good, thank you, Dave. Group 4, Daniel. Are you there, Daniel? Don't forget to Daniel Freire, right? Yeah, Daniel is here. Okay. Make sure you delete your file. Group 5. Okay, group 5 is clean. Group 6 is clean. Okay, good. Most of you have removed your file. So it looks like it's working. Okay. That's just little. During the semester, you will have to upload your Word document. That is what I call the hard copy lab report. And you're going to upload also your spreadsheet, Excel spreadsheet there to this folder of yours. I will download those documents. I will correct it. And you get a grade out of that. That's how I'm going to evaluate you. 32, let's see, 32 students. I have 33 students, someone is missing, right? Okay, so how, you folks, some of you have done labs with different professors, right? And let me show you how I usually do my lab. Okay, but first let's do some plots, some graph plotting. You should know how to do that already because you must have used Excel before, and that's what you're going to do, right? So here you go. I'm going to open a file, an Excel document. Good. I'm going to start from scratch. And I'm going to plot, X, Y versus Y, X versus Y, right? And it goes, let's say 1, 4, 1.5. Let's see what I can do here. 4, 2, 3. Let's see, I'm going to do like that. You know what? Let's do it a simple way. 1, 2, 3, 4, 4, 5. Okay. we have a total of 6 data points. Okay, so we go. So if you want to plot a graph, you should highlight the 2 columns, right? Insert, go to insert, go to chart, plot a scatter plot. This is just an example of how you're going to plot your graph. So let's go to our syllabus and let's follow step by step how graphs are plotted. Okay, so here go. Graphs, if any. The graph must be clean and planned to optimize its space. No large blank areas in the graph. I'll determine the grade of your graph with respect to the percentage of the area utilized in your graph. Okay, so what do I mean about that? Okay, I want you to optimize the space of this graph. I don't want to see a graph in which you have huge blank spaces there in the graph, like in this case. That's a no-no. Okay, don't plot your graph this way, or otherwise I'm going to take out points for that. So make sure you optimize as much as you can. In this case, a good optimization would be something like that. Maybe you can go to 6. Okay, here you go. So you have this nicely plotted graph. Everybody, I presume everybody knows how to. Let me take, let me ask you folks. Let me see if everybody knows how to plot graphs here. I presume you all know. Is Jumai there? Okay, Jumai didn't show up anymore. I'm going to mark it 0 here for her. Plot. Brian Spino, are you there? No. Okay, Lawrence Flores. Are you there, Lawrence? No. Gabriela Montes? No. Angela Padua? Maria Raju? No. Okay, so let's start. Toby, you already know how to plot graphs, right, Toby?
Yes, sir.
Okay, good. So let's see, someone else is coming here, and Daniel Freire. You go. Plot. Okay, Pedro, you already know how to plot graphs, right?
Yeah, I do.
Okay, Kenny?
Yeah, Professor, I do.
Okay, Nolan as well, right?
Yeah.
Harun, already know, right, Harun? Make sure you answer me. Okay, I see Harun here in the list, but I don't hear him replying. Yeah.
Hello?
Yeah.
What did you say?
Yeah, you know how to plot graphs in Excel, right?
Yeah.
Okay, good. Musa?
Yeah, I know.
Okay, good. What about Daniel Nualbo? Do you know how to plot graphs in Excel, Daniel?
Yeah.
Okay, you know? Okay, good. David Nualbo, you too?
Yeah.
Okay, good. Zachary Blue, do you know how to plot graphs in Excel?
Yes.
Okay, there are some details that I'm going to cover with you, okay? So just the bare plotting, you should know, but then there are some details that you may or may not know. Elena?
Yes.
Okay. Luis Easy,
Yeah,
right?
I know.
Okay. David Mass?
Yes.
Okay. Robert Faust? Robert was my student. I'm quite sure he knows. Okay. Daniel Freire?
Yes.
Good. Olivia Kruger?
Yes.
Okay. Chuk Lu?
Yes.
Okay. Amalia Gale?
Yes, I know how to plot a graph.
Okay. There are some little tricks that I'm going to mention that you might not know. Okay. So Tiffany, are you there? Tiffany?
Yes.
Okay. Anthony, you know how to plot, right, Tiffany?
Yes.
Okay. Anthony as well. Safi?
Yes, I do.
Okay, good. Daniel Liang? Yes, good. George Risk? Yes, good. And Ryan McNeil? Ryan also no. He did. Claire Ottinger.
Yes.
Okay. Jennifer Ramirez. Good. Noah Raymond.
Yes.
Okay. Natalie Santiago.
Yes.
Good. Mengshu Zhang.
Yep.
Okay. And then we have Darnis. Darnis. Am I pronouncing correctly? Are you there, Darnis?
Yes.
Away. Okay, good. Cady, Sobi. Oh no, not here, right? Key, not here. Olivia Song.
Yes.
Okay, Sarina Lobana.
Yes.
And Alexis Nigret. Okay, so one of the little tricks of Excel, right? Excel always put in the, by default, when it comes to default, Excel always puts the column on the left side along the x-axis, okay? Always does that. Unless you tell him to do otherwise, which sometimes is a little bit of an effort to do that, okay? If you end up putting, you know, plotting something like that, what is supposed to be in the x-axis, you put in the column to the right, what Excel is going to do? Excel is going to put this column here on the x-axis and this column here in the y-axis. That's a little secret that we usually don't know about Excel. Okay, do you see that? Now the y-axis was plotted in the horizontal direction, and the x-axis was plotted in the vertical direction because of the order of the relative position of the columns. Okay, so keep that in mind, so you know what you're putting, what you're plotting in the x-axis in the horizontal direction, and what you're plotting in the vertical direction. Okay, so now let's erase it here. What else you have to know about Excel? You have to know how to plot a trend line, and it's spelled out in the syllabus. Okay, here you go. Oh, but before you do that, let's label, right? Let's label the axis of the graph. Let's label the axis. Let's, you know, you click the graph, go on chart design, add chart element, axis title, primary horizontal. Oh, here you go. We have it here. And then you have primary vertical. And then you go ahead and label it. Label it with the unit. Let's say the unit is in meters for X, and the Y2, the unit for Y is in meter. Let's say that, right? I usually like those to be bold-faced. Okay, and what else do we have to do? Okay, going back here to the syllabus. Right. Ensure the numbers along the axis are properly spaced. You do not want to have those numbers too close to one another. Here you go. You do not want, and I have seen graphs like that. You do not want anything of this nature encroached with one another, right? I want to be able to read what's in the x-axis. Even if I put 0.2, it's still too close to each other, right? 0.5, let's see, 0.5. Okay, we start to see the numbers there in the x-axis, but it's too close. I think it's too close, so here you go. You can read them better this way. What else? Do not connect each data point by straight lines, okay? Excel has this option of connecting the data points with lines, but don't do that. Don't use that. Here you go. Here's one of them. See that? Yeah, but sometimes it plots the wrong thing too. I don't like that. Let me see if we have it. Okay, this one. That's the one we should be. Yeah, don't connect the data points with lines. This line should come from elsewhere. This line should come from the trend line. Okay? Do not connect these data points with straight lines. Instead, fit the best curve to this data. There is a statistical technique that allows you to do that. It's called the minimum square value. Okay, and it's a technique that minimizes the sum of the squares of the data point in the graph. And it's already programmed into Excel to do that. Here you go, add trend line. Okay, and most of the time I'm going to use a linear plot. Okay, and what else do you have to do? In this type of plot, you will always display the equation in the chart. Do not check the intercept. Do not use do not check the intercept box. And what else you have to do? You have to display the R square here of the equation. This equation here is obtained using a statistical method, and the R square is also a statistical value. Is properly defined. There is a proper definition for this this value here. This statistic is called the R square is called the, oh man, sometimes I forget that. It's written there in my, the R is the correlation coefficient. Okay, here you go. And the square of its value is referred as the determination coefficient. Those values are a measure of how close your regression equation is to that set of data points. Let's take a look. There is a formula for that R square. Okay, if you can go here in the internet, determination coefficient. You can find out what is the formula of the determination coefficient. Here you go. See, denoted at capital R square or lowercase r square. Now use Excel. Use Excel because I'll be correcting your lab report using my own software, and my own software will accept only Excel. Okay. There's you can get Excel from the college for free. Okay, Dave. So let's take a look at the equation for the R square. I never memorized that. The sum of the square of the residuals. Let's see. Oh yeah, here you go. The most general definition of coefficient of determination is 1 minus the sum of the square of the residual. Okay. Divided the total sum of the squares. Okay, and here's the average value of the y's, or the values that are in the y-axis. And what is y sub I? Okay, what's y sub I? Y sub I is, yeah, n values is the values of the, is each value of the y, y1, y2, y3, and so on. Okay, that's how you calculate that, and it's already, you know, programmed automatically in Excel, this value. In this specific case, you got R squared equal to 1, which means a perfect fit. This equation is a perfect fit to this data. But that's because I made up this data in terms of the equations for X, okay? So if you were to say what's the confidence level of this equation with respect to the data points here in the graph, I'm going to say that the confidence level is 100%. Is 100%. In real life, you rarely get something like that. It's very, very rare. And if you get that in real life, you either made a mistake, okay? You're either cheating on your data, or you're using an instrument, a measuring instrument that doesn't have enough resolution. Okay, I have seen data like that. The students didn't cheat, the students didn't make a mistake, but they were using a ruler that didn't have enough resolution in the data, and they got exactly what they were bargaining for, 100% confidence level. Okay, in real life, what you're gonna get? You're gonna get something more like that, you know, off the, you know, 3.9, the data a little bit off. Let's say here's going to be 7.8, you know. And as the data set, because it's slightly off from the ideal case, the R square starts to decrease. Do you see what's going on here? 12.1. Now I'm going to go even further than that, 12.5. So you can see the data point a little bit off. Man, I can go even further than that. Let's see. Yeah, okay. I like that better. Okay, 16, you're going to be 40. Let's see, let's put 14. Yeah. And instead of 20, I'm going to put 22 here. Let's see. Okay. That's what you usually get in real life. I don't like this one here. It's too big of a difference. Let's put 13. No, 13, no, 15. There you go. Okay. So what originally you had for that exact set of data, you had 4x plus 0, right? R squared equal to 1. But now that the data is a little bit off from that original values, it's not going to be exactly 4x, it's going to be 4.2x with a coefficient here. Okay? And the R squared, it's not going to be exactly 1, it's going to be just a slightly off, slightly less than 1. Okay? So that could be more or less what this guy here, we can come up and say, you start to look like a outlier. That's the expression that we use in statistics. Okay? And we do get outliers every now and then. Sometimes outliers are the result of a bad experimental procedure. Okay, so let's see, let's get that. No, not this one. I want to make this other one even further away, 14, right? Yeah, here you go. Become a stronger outlier, right? 14, 13, let's see. Look how it affects the slope. And it also affects the intercept as well. No, I like Google, I like Excel because, in the past, we didn't used to have those types of things. At my time, like 40 years ago, back in 1980, when I was doing my undergraduate work, we didn't used to have this type of software. We had to plot all those graphs by hand. And because it's the formula here is very complicated, very extensive, we wouldn't calculate that either. But nowadays, we can just program that into the computer, and the computer does all the hard work for you to determine those values, okay? So that's what I want to tell you about the graphs, okay? Show how to plot graphs. And 143 already? Man, we have 15 more minutes to go, huh? Okay, so let's do it. Okay, so what is, how do I do significant figures, right? Sig figs. Okay, in my classes, especially for you who's taking a course with me for the first time, okay? I always report the sig figs to the resolution of my instrument. Okay? I want to make things simpler for you and for all of us. Okay, so if you're using a ruler, okay, the resolution of a regular ruler is 1 millimeter. So when you're reporting your measurements, you will report up to 1,000th of a meter. Okay, you don't go any further than that. If you're working with a vernier caliper, vernier caliper, for instance, the resolution of the vernier caliper that we have there at the college is more like 0.1 millimeters. There are vernier calipers that can do better than that, okay? But not the ones that we use at the college, which is 1/10,000th of a millimeter. And for micrometers, again, we're going to use the resolution of the micrometer, which is, here you go, that. Okay. Like that. Here you go. Like that. So keep that in mind while you perform your labs, and then depending on the scale that we use, okay, the scale that we use at the labs there in the, and I will tell you all of that stuff, okay? It's going to be 100ths of a gram, which is, let's see if I have it here. I have write it. Yeah, going to be up to that. 1, 2, 3, 4, 5. Okay, and I'll tell all that stuff. And what about the timer? Timer usually that we have in our calculators in our cell phones has a resolution of 100th of a second. Okay. So basically that, they might have taught you differently when you make measurements with the rulers and vernier calipers, but here in my labs, I prefer to use the resolution of the instrument to make things simpler instead of relying just on the judgment of the student who is making the measurement. Okay. So do you have any questions? I think we have everything. I cover everything that I want to cover, and I'll be working on the data for your lab. Tomorrow we are going to continue the lecture on simple harmonic motion, on oscillations. Okay, today we started just identifying what are the forces acting in a bob, and I'll go into the details. This on canvas? No, you don't forget you have not the PowerPoint, not the file, but I will be uploading there to my YouTube channel. Okay, this video to my YouTube channel. I'm gonna do that. Okay, Daniel. It's our first homework. I haven't set that up yet, so just bear with me because I have to get myself organized. Here's just the first meeting, but by tomorrow you have all of that. Okay, you have this information. But in this meantime, make sure you get yourself set up with Wiley Plus. Okay, have you done that already? Did you get yourself set up with Wiley Plus already? No. Yeah, so go ahead, get yourself set up with Wiley Plus, and tomorrow you have all this information, including my office hours.
Okay,
sequence
so we're done.
Figures, please. Yes, let's go to the sequence figures. This one, yeah, this one right in here. The important thing here is the resolution of the instrument. Okay. Some people use half of the resolution. I prefer to make it simpler. Just this, by resolution, I mean the smallest division of the instrument. Any more questions? Okay, we can stop here and I'll see you again tomorrow. Okay.
Professor,
So see you.
Professor, I'm probably gonna
tomorrow.
wait to. I'm probably gonna set up to wait Wiley plus tomorrow if I'm able to add the class.
Thank you all. Thank you too.
Quick question. Are we gonna use Beyond Labs for the lab? Professor? Professor, can you hear me?
Thank you, Professor. Have a great day.
Bye.